Alright guys, I hope that this works now. God, that's so annoying. Alright guys, unfortunately, that was a bug. That was a software bug. So if you guys can see me right now, then we're good. We're good. Oh my gosh. All right, let's let everybody come back over. Okay guys, I sincerely apologize. My last live stream, it bugged out really bad and the software here did not do its job. So, I had to restart the stream, and that's why a bunch of people are probably going to drop off the stream. I'm sorry guys, I can't control software bugs, and unfortunately there's very few ways for me to test this. Anyway guys, so today what we're going to do is we are going to go ahead and get started, and we're going to go ahead and do this guy right here. Now this is a design that I came up with for training people on how to do utility, which means where the electrical comes into a building from the disconnector through a fuse panel, and how it should get routed safely to an outlet. And I've got two different outlets that I'm going to be showcasing. One of them is going to be a GFCI, and the other one is going to be a standard NEMA 15 amp. Yeah. So it's all good. Hold on, I'm going to notify everybody that the stream is on a different channel now. And again, guys, I apologize. That's unfortunately, that's the way some things work. There's an amazing amount of bugs between the software here and YouTube. Amazing amount of bugs. Okay. Hold on just one moment, guys. I got to notify people that this is the actual stream. That's unfortunately the way that it's going to be. Can you guys hear me now? Yes, I hope. Okay. Ah, geez, that's rough. Okay, so I have a huge amount of components over here, and those components are going to be put in on the board back behind me, to which unfortunately I already explained in the faulty stream, so it's going to feel like I'm repeating myself. But anyway guys, I have two panel boards. One of them's over here and one of them's back here. One of them is going to be set up for utility, which means we're going to basically have an electrical distribution system all kind of laid out. Everything is going to be done with fair rules, because we're going to have to. I have to do everything with fair rules so that I can remove conductors from screw down terminals, put them back in, and do all sorts of stuff. If I look like I'm tired, guys, I'm so sorry, man. It's just one of those things. I do not sleep very much, and especially when I got a big project like this going on. Okay, I think we're good. So, right here is the very rough schematic that I'm going to be following. So up here in the corner, this is my electrical disconnector. Next is going to be some relays. I'm going to have a 3-position switch with a couple contactors, and that is going to enable and disable either my GFCI, which is going to be this one over here, or this one right here is my isolated power. Which is why one of them's got 2 lines coming in, because both of them are technically hot. And this one up here, you can see 1 line coming in. I'm going to have two indicator lights. Like you can see right here's L1, down here is L2. So I've got two indicator lights that are going to be on there. It just is what it is, all right? Bjorn says, everybody's waiting on the other stream. I'm sorry, guys. Hold on, let me get the other stream. Gosh, you gotta hate YouTube sometimes, man. YouTube just does not handle things well. I guess it's free, so I can't really complain too much. Is it really free? I don't know. Hold on, I gotta pop into the other live stream. And I have to tell them, hey, that's not it, this is it. Okay. Well, that's just being fussy. Anyway, guys, okay, here's what we're gonna do. I've got a whole bunch of heat shrink here. Don't know what I'm gonna have to use. I've got my wire fair rule kit. We're definitely gonna use that. I've got some wire nuts down here because there's a good chance I'm gonna have to use that. So I'm not gonna use solid core conductors. A more economical version, excuse me, is gonna be, well, that's kind of cool. So this right here is an outdoor power cord, and it is using 3 conductor 12 gauge, and it's non-solid core. So that means I'm going to use ferrules on it, and that is how I'm going to organize the wiring nice and neat around the board. So on the other board that I'm going to assemble, I don't know, maybe tomorrow or the next day, it's going to be almost all DC power. And since it's almost all DC power, I'm going to have a lot of banana plugs on the back side of it, I think. And that's how I'm going to simulate things like a defective power supply or an open fuse. So I'm going to have a bunch of banana plugs on that guy, and I've got a whole bunch of them. Banana plugs are a liability. We can't use those with mains. Somebody's going to get hit. So it is what it is, guys. Although with the relays and the contactors and stuff, I can simulate a lot of different things on the mains. So let's go ahead and switch up the camera. I have, I know, you can see this is my rough layout for my medical device that I'm going to do. And I've got to custom make a PCB that's going to go on it. A lot of work for this to happen. But the goal is to have 2 boards that have all the components on them, and you can take them into a school. You can set them up, and you can give somebody a multimeter, which I've got plenty, and you can show people a skill that they're going to use for the rest of their life. And that's what I'm going to do. So I do think that one of the most powerful things you can do for somebody is teach a man to fish. Robert, come on, man. Guys. Okay. So I'm going to go ahead and go over all the things that I'm going to be installing over here on this table here. And we'll go into some of the details of those components and why they're essential. Everything's essential. All right, let's do it. Okay, guys, so I do have quite a few cool things over here. This here is an isolation transformer. It does have a few other outputs over here. That's okay. And you can see that I got insulated terminals. What I'm going to do is I'm going to put these insulated terminals on these blocks over here. And I'm going to use those to teach people about secondaries on transformers. So this one here is a 1-to-1. It's an isolation. These ones here are like 24 volts AC and 30 volts AC. But they're going to have their own connectors so that people can test them. And since it's insulated, technically people shouldn't be getting shocked, right? Cool stuff. I do have some old school bus fuses, ground bar. I've got some relays over here, some contactors, and I've got some circuit breakers. I've got a dual gang faceplate. These guys are going to be sitting over here. So I'm trying to make it so that the stuff is kind of spread out a little bit, so it's easy to maneuver, but not so huge. And the board that I've got over here is huge, so I'm going to try and mount everything to the side. So if you see me doing that over there, that's so I can hack off part of the board when we're done. So the goal is to have this nice and neat, easy to follow. I do have a couple fuse holders. All right. So I'm going to have one fuse holder up here. And let's see. Where was I going to set these? Nope. I think these are going to be on the next device. Because technically I've got fuses here. I'm going to have these guys here. Yeah, these will probably be on my next one. And on my next one, I did have allotment for a couple fuses, so I'll save those. All right, excellent. All right, here we go. Christopher Howard says, good morning. Good morning to you, sir. It's going to be a good day. So this here's my disconnector. It's the hub of this entire system, and it's also my emergency lockout. So anytime that I'm teaching people about things, I can lock this guy out with an actual lock, and we're good. Let's pull a chair up. Okay, so the components of this guy right here. Well, let's see. I've got power in lugs and I've got power out lugs, and then there's your fuses right here. So what happens is this bar moves these two bus bars in, and they make contact, and then you have your line in neutral, or your L1 and L2. You can make them live, and then your fuses power up. Pretty simple. Now the cool thing about using these fuses is that, oh no, oh no, I used the wrong type of fuse. That's okay. That's what we have aluminum foil for, right guys? Oh, geez. Of course, I didn't open it to see what type of fuses they were. I knew that they're the screw-in plug type fuses. I didn't know that they were that small. Shucks. That's okay. So we have the terminals up here. We have the terminals down here. So these are the fuse terminals. These ones here are the power input. So when the arm is down, it is off. When the arm is up, it is on. It's a cool little box. Believe it or not, this box was very inexpensive. I got it on Amazon for like 30 bucks. What a deal. So this guy is going to mount up here in the corner, and it's going to have a gland nut like this. That's going to be for the power in and power out. So I have a whole bag full of these gland nuts. You see that? And they're different sizes too. So I got some smaller ones, I've got some medium ones, and I've got these big old guys right here. And that is for these knockout terminals. So when we do open up a knockout terminal, this guy right here will thread up inside it like so. Pretty easy. There we go. Oh, that's kind of a shame. Okay, so I believe I'm going to take out this knockout right here, and then this one right here, because the power is going to be coming off the side of the board. So I believe I'm going to take this guy out right there. And I guess I could just go ahead and start doing that now, huh? These guys here, most of this stuff is rather inexpensive. It's just that, you know, it adds up when you take into account like how many you need. So one of the things I'm going to do is I'm going to have all three of these hooked up to one of my incoming electrical conductors. That is not how they're going to be at your house or out in the field. I'm going to have line connected to one, I'm going to have ground connected to one, and then I'm going to have neutral connected to one. And they will mount on this little DIN rail right here. I do have extra DIN rails, maybe better looking DIN rails. And here's where I'm coming into a decision. I'm going to have to cut this guy probably, because these two contactors right here, I don't have a DIN rail for, and that is just overkill to have a full like 12-inch. So I got to cut one of those. This guy right here is my 3-position switch. That is going to use these two contactors to energize or de-energize one or the other. Or I can keep it in the mid position and they're both off. I'm going to have indicator lights. These are 110 volt indicator lights. So one of them is going to be down here going up to the receptacle, and the other one is going to be on the regular mains going up to the receptacle. So you'll have a visual indicator that something is powered on and it's hot. Again, this is going to be in a training environment, so it's going to be imperative that I keep this as intuitive and safe as possible. One of the things that I have to do first, I'm going to go ahead and just cut this guy off. So this guy right here, it's got 3 sets of secondaries. So it's got the 1-to-1, which makes this 110 volt. We got a 30 volt, and then what's the other one? 24 volt AC. Okay. So these guys over here, I just need to strip these back, which I can't use those. Of course not. So let's go ahead and switch over to these. This transformer is unbelievably heavy. And I believe that this guy came out of a striker bed, if I remember correctly. It's been a while. There we go. All right, there's those two. There's that one. And I'm going to use these insulated spade connectors. The cool thing about insulated spade connectors is that they are protected from arcy spark, you know, even though you shouldn't have any arcy spark because they're all insulated. They're all independent secondaries, and I've tested that. So I've checked it with continuity between each of the secondaries, and they're all independent. So there's no funny wiring patterns or anything going on. And I did test to make sure that this is 1-to-1, although there is a legend right here on the side of the donut that kind of tells you the wire color versus what the output should be. All right, and let's see. Let's go ahead and start crimping some of these bad boys on here. So these are not going to be regular electrical connections. These are just so that people can get their multimeters out and experiment with secondaries on a transformer. There we go. Last one. Oh, come on. It's slipping. Ah, jeez. There we go. Wow. Alexander, Greetings, man. Welcome. Thanks for tuning in, man. That makes me want a donut. Jason. Oh my gosh. Well, it is a big fancy donut. You know where I get this guy from? These donuts right here. That one did come out of a bed, hospital bed. They're using it as an isolation transformer so that if anything does short out, the bed is isolated. You'll also find these in surgical microscopes. You'll find them in the bottom of audio and video towers. You'll find them all over the place. All right. Hey, Catherine. All right, so let's see. So I've got these guys all on here. They're just going to sit there like that. Yes, they're going to be technically exposed, but the key for these is that when people are testing, they can just stick their multimeter leads in. And they're safe because they're isolated. So we're good there. So this guy here, what is the amperage rating of it? Oh, okay. It's 3 amps. Oh my goodness. Okay, well, it's a good thing that I'm not going to plug anything heavy duty into these. So it says on my my 1-to-1s, the black and the whites that are coming out, it's going to be at 120 volts, but it's only at 3 amps. Basically, you're going to pull too much current through this guy. It's going to get hot, and you're going to start having breakdown of the insulation. Good to know. I'm glad I caught that now, because if I allow you to plug just anything into it, you're going to mess it up. Okay. So all of these guys here have screw down terminals. We are going to use fair rules for all of that, all right? So let's see, this guy here. I think the best way to do this guy is with some shrink tube over on the other board. Okay. Anyway, let's see. This guy here, it's got 2 knockouts. And then you're going to have wire nut in, wire nut out. Haven't quite figured out how we're going to do that one yet. That guy's going to sit over there. Okay. I think we're ready to transition the camera over to the board. And let's start doing some installs, man. Some of this stuff here, we're going to solve these problems as we go, because this cord right here is going to get cut up. So it's exterior 3-conductor cord, and it's 12 gauge. So it's nice heavier gauge, and it's a soft and pliable non-solid core conductors. So normally a lot of the stuff that you'd be doing is going to have solid core conductors. We're going to be using fiber core and wire ferrules. So that way there it's just easier for me, pretty much. Have I ever used WAGO connectors? Yes, I most certainly have used WAGO connectors. They're expensive, and I don't normally keep them on me. But I do have them someplace. Okay, guys, let's see. So switch you over. So this is the board that we're going to be doing the installs on. And as I stated earlier, I'm going to be starting up here in this corner. Now this is a jaw horse. I don't know if you guys have ever seen or even heard of that. A jaw horse is a very cool tool, and it allows you to step on this, and it creates clamping force between the 2 ends. And as you can see, I have a 4-foot piece on there. So that is a pretty big piece. Okay. All right. Trying to make sure that the camera doesn't get hit. My #1 priority. So the first goal is to go ahead and set up the disconnect over here in this corner. So let's go ahead and bring that guy over. It's going to sit round about there. So I need to knock out this guy and this guy over here. All right, so let's do that first. There's a few different ways to do this. I think a lot of guys just use needle nose. All right, there's that one. There's that one. So you can see the little discs that pop inwards. So I'm just going to bend those back and forth until they snap. There we go. There we are. 2 knockouts are out. Okay. So for my next trick, I've got these gland nuts, and they are just going to feed on in here. Now it's possible that that knockout left a little bit of debris, and a little bit of debris is going to make this guy really difficult to screw in. All right, here we go. So all I gotta do is secure this collar. Yes. So that is what the finished product looks like. Gland nut installed. Wow, that camera is so dark. Why is it so dark over here, guys? Okay, hold on. Let me move this guy this way. There we go, right under the light. Love it. And if I set this camera over here, you guys got a top-down look. All right. Hopefully you guys can see. So I do have the wrong fuses for this box. I should have known better. It is what it is. We have plenty of aluminum foil. Just kidding, guys. Okay. Set this guy. Excellent. Okay, with gland nuts, it's always easier to loosen them way up. Here we go. And this is going to be my incoming power. There we go. Camera keeps sagging. Look at that. All right. So my incoming power, this is also going to be my power cord. How cool is that? So I need to select a certain length of power cord. Okay, let me test to see how long this is. Okay, so this right here should be plenty right here. I'm gonna go ahead and lay that guy right there. Let's get my cutters, some strippers, and my wire ferrule kit. All right, so right about here. Oh, I just destroyed a brand new power cord. Okay, this is one of the reasons I like this style wire cutter. because you can just go right down the side, just like so. Just graze the outer edge, and open her up. Once you get it stripped back a little bit, then you can usually just pull it and really clear some material. There we go. So this is actually a pretty good power cord. I'm digging it. So it's got some yank strain relief, which is the cord that's on the inside. That's some of this hemp cord that's wound up. That's to help give it some sort of structure so you can't yank it. Because every time you yank on conductors, you're destroying them. No, I imagine that's not stripped back enough, but I'm going to get it stripped back just a little bit, because then what I got to do is I got to thread it through the gland nut right here and into my box, like so. Now I've got two terminals right here, and I've got a ground lug. The ground lug is way up and in there. So I've got to strip it back probably, I don't know, about 9 inches or so. So let's go ahead and do that. There we go. Excellent. Oh, come on. There we go. I should play some music or something here, shouldn't I? Oh, something like that. Let's see. Robert says, I wish I would have got into electronics in my younger days. You are never too old to learn about electronics, man. Never too old. All right, so I believe, no, it's not enough yet, is it? All right, here we go. That's a little better. Okay. So I'm just clipping this hemp. There we go. Let's get rid of all the waste. All right, so the ground conductor is going to come all the way down into the screw down block, and the rest of the cable is going to sit pretty natural up high. I am going to put some zip ties on it that keeps some yank relief on the inside. Gland nuts themselves do have some sort of yank strain relief, but it's never good enough. Never, never, never. So let's go ahead and strip this guy back. And let's get the wire ferrules. So this was I said that it was a 12 gauge cord, but that does not look like a 12 gauge cable. It looks like a 14 gauge. So let's see. It says 14 gauge is the blue. It's these ones right here. I'm actually pretty sure that that looks like a 14 gauge. I could be wrong. I could be wrong. That seems to be going on pretty easily. You usually want to use the smallest ferrule that will fit over the entire conductor. And this looks like it's it. Come on. Yeah, that's fitting on beautifully. Okay, so that's the ones that I'm going to use. So wire ferrules are really cool, very professional and easy to install. That's why I've done several videos on them, because people should get used to what they are and they should be using them more often. Since I'm going to have screw down terminals in here, by me putting the wire ferrule on there, it compresses all those stranded conductors together so they can carry the entire ampacity of the cable. When you put a screw down terminal on, it smashes the fibers outward, so the screw will only touch some of the fibers, some of them won't be touched, and that decreases the amount of amp carrying capacity of the cable. That's what I'm trying to prevent. Okay, so let's see, I've got some flat blades I need. I should have just had all my tools out because I kind of already know what it's going to take to do this job. All right. And for these, wow. And I can feed this ground conductor down here along the back side into the hole. Oh, actually, I've got to go this side because the arm is on that side. And there we go. Sorry guys, if that gets a little too loud. All right, so I'm going to hold it there with the pliers while I screw it down. There we go. So I know that it's not going to pick it up too well, but this right here is why, you can kind of see it right there. Yeah. That is why we use ferrules. This 4K camera loves light, let me tell you. You can see right there how it fits into the tie-down bar. All right. So now these other two conductors, they are obviously not going to be as long, and they're going to screw down right here. And for those two, I'm going to shorten them up a little bit, and I'm also going to do what I said I was going to do. I'm going to secure the cable with some zip ties. So this cable here, you do not want it just flip-flopping around like that, so that's why I'm going to do this. Okay, so I want it to be right about there. All right, there's one. So you can see what I'm doing. Putting zip ties on it, and then I'm going to clip the zip ties. Now, one of the other things I want you guys to take notice of, when I put the zip ties on, I'm not putting the heads of the zip tie next to each other. I'm actually making them adjacent to one another, or 180 degrees out, rather. That way there it creates a wider path. There we go. Excellent. Okay, so see, now that cable can't come out. Even with the gland nut, if it comes loose, you won't be able to get that cable out. Perfect. All right, so these two right here, I'm going to maybe leave these guys a little bit long. Just clip them right about there. I actually probably should have saved those conductors because you might use them as jumpers or something later. There's one. There's two. And I'm going to use the same size wire ferrules. Those are 14 gauge. Okay. Had to be really careful. That went on really tight. There we go. Perfect. So straighten out the conductors. Give them a slight twist. There we go. Perfect. All right, so the one that's going to be closest to the ground wire is going to be my neutral. And the one that's further away is going to be my hot. So both of them are going to be switched with this type of setup. Technically, this is for switching L1 and L2, which in America, L1 and L2 both have 120 volts. But I'm going to use it to switch to neutral as well. So we are completely de-energizing the circuit, which is how a lot of medical devices are actually designed. In America, medical devices, in order to meet the highest quality certification, they have fused and switched line and neutral. So you are removing all the power from the circuit. And the reason that you have line and neutral switched in medical devices is, let's say somebody, some Yahoo, that didn't know what they're doing, let's say they replace the plug end, or let's say the receptacle itself is reverse polarity. So we switch both line and neutral. That way there, in case it's reverse polarity by accident or whatever, you have both conductors being killed. So that's why I'm going to do it here with the disconnector. Just in case, even though I know I'm going to wire it correctly and I'm going to test it, I'm still going to make them switched because that's how it is with medical devices. Okay, so that is my incoming power. It is set. Now I can tighten down the gland nut like so. Sorry, I'll try and keep this in frame, y'all. And there we go. That is a beautiful incoming power. So I can plug this in right now, and my two fuse pots right here would be live. There we go. Okay. So the very next thing, let's see, what can we do? What can we do? So there's a few things that I don't really understand. So let's go ahead and get a multimeter and let's check it on right down here on these bus bars. Let's see, where's my fluke meter? What to do when you have so many meters, guys? Sorry, guys, I haven't been following the chat. Pharaoh's rule. Yes, fair rules are indeed the only way to go. Okay, so on this device right here, there is a legend on the inside. I don't necessarily trust legends. I always want to meter things out myself for continuity. Okay, so this right here is this guy. Okay, so this terminal is the outside of the fuse body. Okay, that's interesting. It's just a common bus. Okay, well, I didn't know that about plug fuses. See, we learn something new every single day. Hold on, let me get a plug fuse. Now these are the wrong type of plug fuses, but you guys are going to get the point. So you can see on these ones here, the conductor is actually on this ledge instead of on the sides. That's why they're the wrong ones. But the button itself is hot, like all the time. I guess that makes sense. I always thought the button was the switched component, like when you switch this guy on and off, but it is always hot. Well, where is it? Okay. So the button is the switched component. All right. Excellent. And the outer ring is going to be the fused component. Okay. Understood. And then I've got this little bus bar down here at the bottom. I don't know if you guys can see it too well. So this bus bar appears to be insulated from everything. It's just sitting here at the bottom. And the legend does talk about a bus bar. It says load charge. Load charge. I don't know. That's goofy. Because this guy does not have any continuity with anything else. Just to be sure, so I don't archy spark something out. Yeah, see, it's not even connected to chassis ground. So that right there is probably for your neutral. That's what I'm guessing. So you can control L1 and L2 here, and this little bar right here is probably for your neutrals to screw down. And this right here, because it's a common neutral, and this right here is going to be for common ground. Okay, that makes sense. Just is what it is. I wasn't expecting that. Okay. Well, I'm switching line and neutral. So let's see. This one here is going to have to come up through the gland nut, like so. And this is going to be my fused line. And let's see, hold on. Let me position this where it's going to sit on the table. Probably right about there. And here, you can see how things can quickly get disorganized. Here, let's move all my tooling. And yet another one of these guys to secure this guy. Okay, here we go. So this one here, I need it to come up to all three of those circuit breakers. So I need about that much cord right there. So what, measure twice, cut once? Isn't that what they said? All right, so let's go ahead and strip this guy back a little bit. I only have to strip it back to like here compared to the top. And that's because the ground conductor had to reach all the way down the box. There we go. That's actually pretty good right there. Look at all this fiber that they put in there. Okay, here we go. Let's clip this. Excellent. Now we gotta redo the terminals. Since I'm gonna be using a lot of 14 gauge, I'm just gonna dump this guy into its cute little bin right here. I already know I'm gonna be going through some 14 gauge. All right, that's better. Go. This might actually go a little bit faster than I thought it was going to. Fair rules make things so much easier when you're talking screwing down terminals. Because often what will happen is you go to insert the wire and it'll fray out, and then you got to pull it out and you got to reorient the strands and then do it again, and this is going to make it so much easier. There we go. Okay, so here's where we have to be very assertive on the color coordination. Put the fuse all the way. I'm going to put my zip tie on here. Right there. Excellent. Okay, that's my strain relief. And black on this side, white on this side, neutral. Very important, of course. So yeah, I've got some big plans, y'all. I've got these plans to go out and approach kids like in their environment. So going to those schools, talking to people in person, and teaching them skills. So that's why I'm doing all this. Okay, so for the ground wire, what I've got to do is grab onto it with some pliers. There we go. These terminals do screw down pretty tight. There we go. Now, it looks like there is a square drive that they use for these terminals. I didn't know that. I thought they were going to be Phillips. But this Square D, looks like all these screw down terminals are square drive / flathead. Interesting. You know, I learn something new every day too. Square drive is probably so that you can set it in a torque wrench and you can torque it down, because there is very specific torque settings that you're supposed to be setting for these if you install it on a house or at a business. All right. So here we go. There we go. All right. So that's it. Power coming in, power coming out. I've got a common bus bar, and both line and neutral are switched. That is this guy. It's going to live right about here. So let's find some fasteners and drive it in. First component is ready. Excellent. And to secure this bad boy, I've got some of these little dingle hoppers. No, they're not too hefty, but I might do some through-hole like fasteners with acorn nuts on the back. Just not right now. Takes too much time, so I'm just gonna do an install, and then later on I can come back through and do a final install. Let's see. So right now I'm looking for my Phillips bits, which, geez, yeah, I've got so many of them. All right, here we go. So I'm going to use the extension and number 2. There we go. That way there I can get right down in there with my impact. And let's see. Yes, sir. Okay. So I'm going to set the first one, and then I'm going to make sure that the box is level. And then I will sync the second one. There we go. There we go. Actually, those guys are holding pretty good. I might not need to do through-hole fasteners later. Oh, yeah. Perfect. Beauty. So there's my switch panel. So the key is that when I'm working on the system or while it's plugged in and we're just going over theory, you can actually put a lock through it right here and you can lock it out. So the whole entire setup is safe while it's plugged in. And then you can take the lock off, turn it on, energize the circuit, and now you're ready to do some practicals. Excellent. Well, that was easy. I guess might as well keep these fasteners out. I'm probably going to use them again. Okay, so the next thing that I want to do, we're going to keep up with the flow, and that is I have these 3 breakers right here. Now, they came with a miniature DIN rail, which maybe is big enough. Yeah, that's big enough. So normally when they're installed in a commercial environment, they're going to be jam-packed next to each other like that. I was thinking about spacing them out a little bit, kind of like that. But regardless, this DIN rail is what they sit on. You can see it right there, how it mounts. Pretty simple, and it's got this little latch right here that you pull on it with a little flat blade screwdriver, and it's going to pop them off the DIN. Super cool. I love working with industrial electronics. It's almost like they thought this stuff through. Bjorn says, is that fiber fire resistant or fire retardant? What fiber are you talking about, man? Oh, the fibers that are inside the cord? Well, I would imagine that they're almost definitely fire retardant. But I could be wrong. Maybe they're just fire resistant. But it is just regular, it's cotton, or it's going to be, sometimes it's polyester, or yeah, it's poly. These ones here, I don't know. It's mainly for yank resistance. Okay, so this box is on. Next, I want to mount my circuit breakers, and I'm thinking about mounting them right about here. Okay? What do you guys think? That way there, you have plenty of room for this. And this cable here is going to route beautifully, just like this. You know, 1, 2, 3. That's my incoming power. That's my outgoing power. Pretty easy. Should be beautiful. So first thing first, let's go ahead and mount our DIN rail right here. And let's see, how high do I want to mount my DIN rail? This is a, well, I have a machinist square version of that, but it's a square. And you can see how it's got a flat side right here. You sit it flat against your material. And this here allows me to set a marker for how high I want it. So right here, it's a 1 inch, 2 inch, 3 inch, 4 inch. So let's do about 3.5. And what I can do is mark it. Oh, do I have space? Oh no, I don't have space. Oh well. 3.5 for this guy. It'll be right about there. Okay, that should be pretty good. Right about there. Perfect. Next thing is those same fasteners that I had before. I'm going to go ahead and use just 2 of them. There we go. Okay, so I'm checking from the edge of the DIN to the top of the board. Come on. So notice how I always fasten one side and then I leave the other side like I did with this one so that I can move it. So this looks like 16. Right about there. Even though I marked it, the ruler doesn't lie. I'm sorry if that is really loud for you guys. I know it might be. Okay, so these DINs, these circuit breakers, see how I put the flat blade in there? Just kind of pops on. It really is that simple. Just like so. There's a little slot. Ta-da! Here we go. And there are caps that you can put to lock these guys on. I have not, I don't have any of those. So they're little caps that come in here and they screw down. That way they don't move. I think they'll be all right for the moment. So this guy right here is going to come up to here. Say just like that. 1, 2, 3. Okay, so I need to cut this guy right about here. Excellent. Might have to switch the camera angles, y'all. Let's see. Let's do it. Why have a wireless camera feed if I can't move the camera around? There you go. Maybe that is a little better. I'm going to wind the installed power cord up so that it doesn't drag on the ground and get all dirty. There we go. Let's put the square back. All right, so between this and this, I'm going to bring it up like that and separate it out. That's what I gotta do right now. I'm gonna strip it back probably about 3 or 4 inches. Let's say 4. You guys are probably seeing several different techniques for stripping back the outer insulation. That type right there, using flush cutters, just walking up the outer conductor, or the outer insulator like this. And then you just peel it. That way there you don't damage the inner ones. Creates a weak point, allows you to just pull them back. Kind of like that. All right, now let's clip this guy off nice and beautifully. All right, so here's where we gotta step up our game, all right? Let's pull all this down. Let's clip it. Come on. All right, so this does not look good. So let's go ahead and let's terminate that a little bit better with some shrink tube. And I've got this one right here. Too much. It's too much. We're going to cut that in half. I'm using dual layer shrink tube as I do in almost everything I do. It's because dual layer shrink tube is so much better when it comes to being a functional shrink tube. Okay, here we go. Let's leave that one there. Right there. Beauty. Let's square it up, make sure it goes on nice and even. So dual layer shrink tube, it's thicker, it's more rigid, and it's got a glue on the inside. And you're gonna see some of that glue kind of squirt out the two ends. And that is when you know that you have shrunk it down pretty well. I got a little bit of the glue starting to squirt out down here and up at the top. Excellent. Okay. I could shrink that down a little bit more, but it should be good. So you guys can see the difference is it looks much better when it's terminated like this. And the way that I'm going to do it is going to be ground conductor, then neutral, and then hot. Hot's going to go over here. Again, we have screw down terminals, so we're going to be using more fair rules. So you can tell that this is rinse and repeat, rinse and repeat. There we go. Nice. There we go. Nice. Perfect. All right. Oh, these guys are Phillips. That makes it a little easier. All right. Excellent. Neutral. All right, perfect. So these little circuit breakers right here, they're pretty cool. I believe that these are rated for 20 amps. Yeah, they're C20s. Okay. And they have little indicators on them versus the ones that might pop like halfway between, and that's your only indicator that it tripped. These ones here actually have a red and black. So you can see immediately what your status is on them. So the whole reason that I've got it set up in this particular way is so that we can change the conditions. So in other words, like, let's say I want to set up a condition so that without isolated power, we can test leakage. In other words, let's say we want to induce leakage and show how that leakage pops up on your electrical safety meter. We can open the ground, and then we can create the leakage condition. and it's going to pop up because normally the ground would, you know, take some of those extra leakage currents and, you know, seep them away. But anyway, I can also open the neutral. So let's say a device might have a defect. I can open the neutral, and then you will find that defect, maybe on the battery charge circuit or something. So there's some cool features to be able to play around with those. I do need to screw these guys down. That's going to bug me for sure. So anyway, Dental Equipment Repair Channel says, nice heat gun. Thanks, man. It is the Milwaukee. It's the M18. While it might take a little while for it to heat up, it is a powerhouse and it's portable. And that is so important. Dental Equipment Repair Channel also says, if I lift ground, won't there be an increased risk to the learner? Yes, absolutely. Yes, 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 100% yes. Is that realistic? Yes, it is. Most certainly is. The good thing is that the device that's going to plug into this board is probably going to have a DC power supply. Matter of fact, I know the device that I'm going to build out, it does have a DC power supply. So that means that it's going to be isolated anyway. Also, it's really important to learn that with a defective ground, your GFCI is not going to work. That's going to be, you know, there's like 100 different experiments I can run with this since I have the ability to manually trigger my ground. That is going to be a huge point. So I know some people are going to voice their opinion on why am I running neutral through a circuit breaker, yada, yada. None of this matters, guys. So I've got multiple levels of redundancy. I've got the fuses that are in my disconnect. I've got the circuit breakers. And then I'm going to have the 3-position switch right here. So these lines here are going to come down to the 3-position switch. And that guy is going to do some magic. All right, so let's see. You can tell my surface here is just collecting tools very quickly. All right. So the 3-position switch, while I'm talking about it, let's go ahead and bring some of these baddies out. So one of the things that I wanted to do is the ground, I want it to come down to a ground bus bar. And one of the reasons I want it to come down to the ground bus bar is because that is going to be a reliable point of measurement. Because on normal systems, you reference everything to ground, which means you have neutral, which is at ground's potential, and you're going to be able to measure that. You can measure it right here to right here, or right here to right here, but you're going to have a bus bar like this in your circuit breaker, in your panel. So it's important that you know that this here is a reference point. So here, let me tighten this guy down a little bit. I like how it's got a common ground so that if this was metallic, it would be part of the system ground. So I'm going to make this wire here nice and neat, probably like so. I don't know, maybe like so. Yeah, probably something like that. And then the ground terminal is going to be over here. My 3-position switch is going to be over here. Let's go ahead and set that guy up right now. And if you guys think I have everything kind of figured out, you would be dead wrong. You would be wrong. But that's okay. You know, that's half the fun of doing these projects, right? I don't have everything figured out. That's no fun. Okay, so each of these end blocks, you just got to take the fasteners out, and there's going to be a knockout hole right there. It's funny how they made this very simple. Once you start studying on how things are made, you will start to realize about why things can be produced to a certain cost point. And this is no different. So I have, there we go, let's put that guy down. So this guy right here, it looks like it's an injection molded component. And then this right here is just a two-piece extrusion. So you can see it's got a C channel, then it's got a cap. And it's just threaded into these channels that run down the length of it. Very simple, man. Very, very simple. And for the second one, all I'm going to have to do is take off the top two right here. This one and this one. It's where I need my disassembly mat so that I can keep track of the fasteners. So you can see how the two channels made up. So all we have to do is take this guy here, take off the retaining nut, and then it's going to feed through just like that. Now, here is where it gets a little sketchy, because inside this guy, you can see how it just kind of rotates around like that. That is going to give me some problems, because I'm going to have mains on these guys. Okay. So it is 250 volt rated. It's just, in hindsight, it's not that good of a plan, because it's an aluminum, it's an aluminum body. We're going to make it work, guys. Let's take off all those retaining rings. Beauty. There we go. It's a lot more stable without all that garbage on there. And this guy also has a little legend that fits on the top. Just like this. On, off, on. Like so. Come on. Just like that. And this guy goes on. So I've got to be extra careful, because we don't want this guy to move around inside the body, because if it moves around, we are going to have some problems with arcy sparks. Come on. That is not cooperating too well. There we go. Okay. So what I'm going to do is I'm going to inject some polymer down the two sides right here so it stays nice and centered. We don't want this guy turning so the terminals can be touching the sides of the block. In order to do that, I got to pull out my faithful DeWalt gun right here. All right, so this guy right here is going to be my next one. Bjorn says that metal box also needs an earth connection. Yes, it does. Yes, it does. Everything will be done in due time. All right, so let's see. That's cute. That's really cute. I'm waiting for that gun to heat up so that I can inject something right here. So this is a 3-position switch. So it's on, off, on. And I'm going to have it set up so the middle's off. Top is going to be normal voltage. Down is going to be isolated power. Pretty simple. Oh, here we go. Now the glue isn't actually holding anything. What it's doing is it's creating a spacer. You can see right there, it's creating a spacer to keep this guy centered so that it never rotates. Because if it rotates, it's going to be sparky spark time, right? Now there's a lot of applications for glue guns, but they are an insulator. So if you want to secure electrical components, you can do it. You can do it. Makes not on medical devices. Watch my words, guys. But something like this, you can see how I've got it kind of sandwiched between the two. Now, once that cools off, which I've got an air conditioner right here above my head, oh, it feels so good. Once it cools off, this guy here will be ready to get installed. So let's set it right here. All right. I'll take care of this bad boy. Perfect. Okay, a ring connector with a rivet to ground in that box. Well, yes, and that is just going to be part of it, man. Just going to be part of it. So one of the things that I've got to deal with is the fact that these guys are not that large. Okay, so you can see the size diameter of these and the cable. Wow, that's kind of cool. Look at that. It's on green screen mode. So there's a size discrepancy there. But what we can do is we can drill it out and we can put larger ones in. You can see we've got plenty of real estate with the knockout plug. So all we got to do is drill it for the larger ones. Keep going. And I have a whole bag full of these, so I've got plenty of them to sift through. Just like that. Perfect. There we go. Okay, so I found the two. I can take the two original ones, save those for later. Let's switch the camera back. Okay. So, let's see. There we go. Okay. Hopefully that stays in frame. Wow, that really zoomed in fast, didn't it? Okay. So I've got this cover, and this cover, I want to drill them for the larger gland nuts. Gosh, I should have a screwdriver set up for a #1 Phillips, like a electric screwdriver. Everybody knows I've got plenty of them. Okay, so since these guys are slightly elevated, that's what I'm going to do is on the C channel right here, I'm going to grind away at the bottom just a little bit and create a patch where it's nice and fresh so that we can get a good ground point. And that is where our terminal is going to screw in to ground out this box, because reasons, right? So what I need to do is I need to drill this guy so it's large enough for that hole. Let's do that right now. And am I too lucky for a step bit? Okay, the step bit's gonna work. Heck yeah. Nope. All right, let me get my safety glasses because I know somebody's gonna point it out. All right, here we go. So this right here is the part. Notice how I'm going nice and slow. All right. So notice how I went nice and slow on that. It is just what, PVC, so it's real easy to cut these holes out. There we go. I'm fortunate that it's the perfect size for this entire step bit. That's so cool. There we go. All right. Almost the perfect size for the step bit. Almost. All right. I do have a larger step bit. Of course. Here, let's move all these guys over here. We got some metal shavings, plastic shavings, shavings. There we go. So it's still a little tiny too small. I do have other step bits. Okay, so I need to take it up one more size. All right. Yeah, she's taking off some plastic now. Let's see if that was enough. I'm trying not to hog out a huge amount. Oh yeah, perfect. Okay. Try to take it nice and easy. All right, so we can put this guy on here. Beauty. Okay, and there we are. So there's one. Let's do the second one. All right, I just did that by hand real quick. Beauty. All right, that's how I want it. Nice and tight. Okay. Yes. Okay, gland nuts are installed, at least for the moment being. We're done with the drill. Okay. So now we're ready to wire in our incoming power. So it's going to go like so. Maybe like so. Trying to figure out the length of how much I need. Right, that should be pretty good. Okay. We gotta deal with this guy now. And there is a variety of different ways that we can scar this guy up. Oh, let's see. What would be the best way? I do have some wire brushes. Stainless steel will strip the coating right off this. Oh yeah. There we go, down the bare metal. Right there, you can see it. So the key is we want to make sure that we have good contact points. Up here at the top of the box. There we go. So I'm stripping away the paint here and here. And the lid, which I'm allowing to cool. There we go, nice and cool. Now look, that switch is going nowhere. So what I'm gonna do is I'm gonna run my brush up and in here, or no, I don't even need to. I got my screwdriver. Strip away that paint, make sure that we got good contact. Beauty. And all this can be tested with continuity or ohms. See how good it was done. Okay, there's one side. Let's go ahead and do both sides. All right. So I want good contact between the upper and lower, just like that. We should be good. Okay. So now what I'm going to do is I'm going to strip back this cable here a little bit. I've got to separate out the 3 conductors for the circuit breakers. Ow. Got me. That is the worst part about these ones here. If you don't watch it, your skin will get in between the two, and they will cut your skin just as fast as anything. Okay, how's that? Now you guys can see why I prefer using the flush cutters. It's just a cleaner cut. There we go. Beautiful. So I'm going to need my heat gun again. And I saved a chunk from my heat shrink to fit right here. So it's nice and terminated beautifully. Right there. You know, one of the things that's making this heat gun seem a little bit slower than it normally is I'm right in the path of this air conditioner. So, I mean, it's definitely going to slow it down a little bit. Almost looks like it's going down a little crooked. There it is, beauty. It's all about presentation, you know. It's hard to go around and talk to people about professionalism if the product looks like garbage or it looks like it was done in my garage, which it was. But I'm going to be going to schools and stuff with this, so that's why it's got to look as professional as possible. So there's one other thing that I'm going to do for this guy. Let's see. I guess I can just cut another section off the cable. Let's see. Ah, shoot. Alright, sorry for the loud noise, guys. So, the other thing I need to do is I'm going to tie in this ground with this ground, and I need another ground conductor in order to do that, to make that happen. And I think in order to make that happen, I'm going to use one from this cable right here. So let's cut it, see right there. Okay. There we go. So I got a couple extra conductors in case I need to, which I'm almost definitely going to need to. So I've got to strip this guy back and strip this guy back. Like that. And like this. And for this one, I have to step it up to the next size up ferrule because I'm putting two conductors into the same hole. There we go. Hopefully that one's the right size. I might have to go like one size even bigger. So what I want to do is I want to put both these conductors like this in the same ferrule. Like that. So this one is not going to be big enough. Step up one more. Okay, now I'm up to 10 gauge, I believe. Oh yeah, that's better. So the goal is to have both of the outer jackets underneath the sleeve. Just what I'm doing right there. And now we can crimp it. There. Looks beautiful. Now we can crimp on these two. Let's go back to the 12 gauge. Let's do this one. Perfect. Wow. Okay. So this one here is going to come down to the terminal block. Let's cut off all this extra garbage. I'm trying to keep all my trash to a minimum on the table. Okay. There we go. This guy here. Beauty. You can see I got a little bit of conductor sticking out of the ferrule. Just cut it off with flush cutters. There we go. Alright, so this one here is going to screw down to my bus bar, like so. Yes. Okay, so now this guy should feed in to my circuit breakers like so. And presentation-wise, it should look really good when it's done. Notice how I'm holding on to the circuit breakers when I go to crank it down. You don't want to put any of the stress on the DIN. The DIN is just there to hold it. It's not really for structural support. You don't want to put all that kind of torque on a piece of plastic. So that's why I'm holding them like so. Yes. Okay. So I can move all my components to the switch box down. Yes. So mind you, when this is done, that's when I'm going to secure these cables and make them look all nice and pretty. So right now they're just flopping in the breeze. That way there I have some leeway to move stuff around, in case you guys are wondering. So this bus bar, I don't know, I might put him like right here or right here. I don't know. But it is pretty important to have this guy next to your circuit breakers. Let's see, do I have any fasteners for that guy? Hold on, let me screw that ground terminal down right now. I swear to you guys, I probably have the most fasteners out of almost anybody you guys know. And that's just because I'm constantly working on stuff. All right, let's see. Well, those are good. I'm trying to find some fasteners that won't stick out the back of the board, which I think is going to be the problem. Ouch. Is this one? Well, if it sounds stupid but it works, then it's not stupid, right? Okay, well, I guess I can remove my eyewear now, huh? Bjorn says that will be a very tight box inside. Yes, sir. Milwaukee does make everything, almost everything, heat guns included, which is one of the reasons why I switched over to the M18 platform, is because they use the same charger as the M12, which makes things very nice for me. Okay, so here's my ground terminals. Oh yeah, that's, geez, those are way too long. What about the same screws I was using earlier? All right, that's better. It's not perfect, but it's better. Come on. One, ouch. And let's see, two. All right, there we go. I might move that later. We'll see. Okay. So, all right, so this one right here, it's going to come in through this gland. I guess let's go ahead and assemble part of it. Hope you guys are having a beautiful Labor Day weekend, man. I know I always try to plan some sort of project or something for these long weekends, because I get really uptight if I can't finish a project, and that is why I invested a lot of money and time into this one, so that I could make it happen kind of quickly. Okay, so here's this one, which, yeah, you guys can imagine it's definitely going to be a tight fit. So we're going to do a common neutral inside this box, and then we're going to do just switched hot. So my incoming power is going to be the yellow, but I think my outgoing power is going to be 2 other conductors, because ground is not going to exit the box. And hopefully we can use these guys. Might be a little too tight of a fit in the box for those. We're going to find out together. And shoot, I do have these guys here, so I should use ring terminals. Which, yes, I do have ring terminals. Okay. All right, let's do this. So this guy here, I need to strip it back. Let's say 3 inches. There we go. Nice. I wish I had somebody that could read the chats to me, like, while I'm doing this. I do have a way for people to call in, by the way. I've got a WhatsApp number that is registered for my live streams, and I just, even though I've got my WhatsApp number here, I don't really have it set up yet. Like, my phone is over here, and it is Bluetooth to my thing, but I have to like activate it when somebody calls in, you know, accept the call. So right now it's a little pain in the butt. I'll figure it out. Okay, so let's strip this guy back really good. As Bjorn already said, the box is definitely going to be a little crowded. So this guy right here is our most important one. We're going to go ahead and put a ring terminal on this guy, and it is going to be grounded straight to the bottom of the box. And let's see, that would be these ones right here. The neutrals are going to be tied together, and the hots are going to be switched. Pretty simple. Definitely going to be tight inside the box, though. It's going to be a nightmare. Let's see, where's my heavy-duty crimpers? I would lose my head if it wasn't attached, guys. Oh, over here. All right. Okay. So I've got some heavy-duty pliers that I'm going to use for this, because they get a much better crimp. Yes. So this guy here is going to be screwed straight into the bottom of the box. The neutral is going to have a common. It's going to be common crimped, and then this one here is going to have a ring terminal. Let's see. Actually, yes, I've got mini ring terminals. There it is. Nice. Yes. Okay. And then this guy here just needs to be stripped back. So. Okay. Now I have some cable that's going to go to each of... How am I going to do that? this guy here is going to have my hot switched. Neutral is going to be common. And then it's going to run over here to my relays. And these guys will also be mounted on a DIN. Let's consult my funky drawings so that we can see where we're at. Okay, so on my funky little drawing, I'm currently working on the 3-position switch, but you can see we have 2 lines out. So I got 4 conductors that need to leave the box to my 2 relays. I could have done this so much simpler. Okay. You can see how I tied my grounds in together. No problem there. I could have ran a... That's what I should have done. Is it too late? I could have just ran a 2-conductor up to my breakers. Okay. Yeah, this is just in CAD. Done in Microsoft Paint because I can do things really quickly and I can change things around. Although I should actually use a CAD program. So you can see my lines are coming in straight from the breakers to the relays. And all I'm doing now is the control wiring for the relays. So let's see, this guy here can go up to the relays. I could do that. And then all I'd have to do is have a second terminal coming into here for my switch. I don't know. This is a 20 amp switch, so So my delay right now is because this was just supposed to be a signal voltage. The main output for these was supposed to go straight over to these. Okay. I need to make these doubles. Okay. Yep. So I'm going to drill the bottom of this box. Let's just go ahead and drill that guy out right now. I don't want to just drill it into nothingness. Here we go. Yeah, right there. And now you see why I put down the second block of wood. Okay. So my ground is going to come in. And it's going to connect just like that to the bottom. Nice. I need these guys here to be doubles so that I can feed the breakers directly. Or the relays. I don't even really need the contactors, do I? I kind of wanted them on there. That way there we could troubleshoot contactors as well, because you are going to have mains contactors. Jeez. They're supposed to ship me 2 of the exact same ones, and they messed up. One of them is a 500 volt rated, and one of them is a 250 volt rated. Are they the same? I guess they're the same. Just different color. Different build. Okay. So let's see, this guy goes down here. This guy's common. And my incoming power is going to be over here. Let's say another stretch of cable about yay long. No, I don't use a pen. I use a mouse for all my drawing, man. Okay. I could set some music or something on for you guys. Could easily do that. So my incoming is going to be here. My 2 outgoings are going to be here. Wow. That is definitely going to be a tight little box, as Bjorn already stated. Come on. All right. Cool. So this guy's going to be like that. This guy here is going to be like that. Beauty. Not so bad, guys. We got it. We got it. So I do have to redo these guys up here because they're going to have to be doubles. Let's see. So my output from this guy, from here, over, let's say about that long. There we go. So what I've got to do is make it come from up here and come down to these guys. And I don't need ground. So all I need is line and neutral for both of these. And then I've got to make them in parallel. Okay. So the way that these contactors work is you've got A1 and A2. It's the little terminals right here and right up here. And imagine this as a dual pole single throw switch. So I can do both line and neutral. I can turn them both on and off together. And up here, it's going to be 115 volts to switch it. So I could have changed the voltage, but I figured let's keep everything on this board on AC with mains potential, which is 120 volts here in the United States. Should ask guys if they're interested in taking bets on whether or not this catches fire when I power it up for the first time. Let's see. Let's see if it catches fire. Okay. Come on. This cord that's inside the cable makes it really difficult to cut. Okay. So that could be my 3 up there. I don't need ground. And these ones here, I need to run in parallel. What would be a beautiful way of doing that? So I would like them to be running in parallel on the input side. That way there, you know, the cool thing about these is people can use their multimeter and they can test and make sure, okay, we got power incoming. Right here we have exposed contacts. Although they're recessed, you can see, is it energized? We can feel it. Not only is there an indicator, but we can feel it, you know, or with our multimeter right from the top. So I would like to have these, although they're not necessary, I would like to have them to show people how to troubleshoot contactors. Okay. Anyway, let's see. Okay, guys, I know how I'm going to do it. It just took me a moment. So this one is going to be like this. So I'm going to run my ground over to my common ground bar. And this one is going to run over here. Those two are going to go up there to doubles, which means I need to disconnect these two. So when I say doubles, you see how these ones here are just singly put in there? I would like to run 2 out of there. I might be able to do it. Hold on. Not a best practice, guys. Don't jump down my throat about it. I already know. But I feel like it's going to happen. I feel like it's going to happen, man. Music is distracting. All right, guys. So let's cut this guy right here. Out he goes. And let's see, do I have enough space? Maybe a little bit more. Okay, guys, so what I want to do is make sure that my ground conductor's got plenty of space to head over to my common ground bar. There we go. So now let's put this guy here on, like so. Perfect. I'm trying to make it as tidied up as possible, and these little strings keep fraying out. God, they're driving me crazy. All right, let's just put this guy back on, like so. Just like that, right there. My heat gun, again. Now my soldering station right behind me has a much hotter heat gun because it runs off of AC. AC is just a more efficient energy. Come on. There we go. There, it's got a good glue adhesion. So the trick is just to make it look nice and beautiful. Let's go ahead and strip this guy back. Put a terminal on it. And these two. Now, one of the cool features of these type of automatic wire strippers is I do have a length of pull gauge, which is you put it in until it hits the stopper. That way there, all your wires are consistent. I do it by line of sight, and I can come really close with line of sight because I've been stripping wires for many, many years now. Perfect. That's it. That's a good fit. Nice. Okay. So this wire is going to come up here and it's going to feed my breakers. So it's got to come up here, like so. Which means I don't want this to all look like a tangled mess, but unfortunately it's going to in some ways. Okay, first I'm going to secure my ground in my bus bar. All right. And next, I'm going to run them in parallel to my other crimp terminals. I know, guys, this is very taboo, not something you're supposed to do. I should remove those old crimps and re-terminate them so that they're in the same fair rule, but it's all right. It's not like I'm going to run a lot of current through here. There we go. Yes, there we go. So you can see I've got them running in parallel to each other. This one's going to come down to the box. This one's going to come over and be my feeder for these guys. So now I got to strip this guy back. And it does have a ground. Come on. So it does not have to be stripped back very far. Perfect. So right there. That should be as long as I need it. All right. All right, so here's my 3 conductors. I'm only going to use 2 of them, so the third one right here is probably going to, I do have a second ground bar. I think I should probably use the second ground bar over here. Yeah, for sure. Okay, so the reason I'm going to use the ground bar over here is because this guy is going to tie into it. But more importantly, it's because I need to feed a ground over to my gang box, which is going to be sitting over here on the side. And I'm going to be switching only my line and neutral, not my ground, from my contactor. And I've got isolated power, which is going to be down here. So my isolated power is going to need a ground run as well. So that's why I'm going to have a ground bar. Yep, that'll work. Okay. So one of the things I do not need is all this cable. So I'm going to strip it back a little bit further. There we go. Yeah, that's better. Tell you what, didn't I have scissors? Utility shears can do wonders in the field. Look at that. So much better. Okay. It looks so nice. Okay, and then I've got the shrink tube for this side. Beauty. So it will sit right there. Shrink it down. Let's make sure the shrink tube is all the way down. Now, a more correct way to do this would probably be to use the metal whips with the solid core conductor, but it's much more difficult to work with in these short these short spanses. So I would rather use flexible core any day. Plus, it's much easier to make the cables nice and beautiful. Home wiring is normally going to be solid core, well, almost always. And commercial wiring is almost always solid core. So there we go. All right. So one of these is going to be terminated for the ground bar. This one. And that's this one. Hold on, let me get the schematic so that you guys can see exactly what I'm working on. I don't want to jump over anybody's head. And if you guys have any questions, go ahead and ask. I know I'm not like over here reading them every single moment. I'm gonna need wind wire. You watch. I'm gonna get all that shit in that box. You watch yourself. It's gonna happen. Haters gonna hate. Now, I do have a lot of garbage on my table here. Okay, so this one here is going to come over and feed these. So I need to double this. So I need just a short one, like so. Let's see, where's my cutters? These guys. All right. Now the reason I cut this little guy off right here is because I need these two conductors right there. That one and this one. I do have a spare ground conductor. I'll leave it over here just in case I need it for something. But these guys here, I'm going to strip them back like so. So, right, and I'm going to go ahead and crimp these guys with terminals. Perfect. Beauty. All right, so now I gotta strip back the other sides of these little shorty wires. Okay. So now I've got these trimmed back. Let's trim these back. And let's see, I think this here was the size that I used. Beautiful. It should be 10 gauge. So here's where it gets super sketchy. So I'm going to put both these two here and put them in the same ferrule. Just like that. Give them a crimp. Yeah. And the two whites. Come on. Oh, come on. That's why we use ferrules, so that type of garbage right there doesn't happen. Beautiful. Okay. So that which I just did is what I should have done up here. I get it. I put two of them in the same screw down block. Not a good practice. And what this allows me to do is to run two of them like so in parallel. You see that? So we can switch hot and neutral on two of these guys right next to each other. So the very next thing I got to do is I got to cut a piece of the din right here. Just wide enough for both of these to sit. So technically I can cut the din right there. Oh, right there. Okay. Let's do that right now. And I've got a whole bunch of different saws, but today I'm probably just going to go the easy route and just use this guy. So let's put the safety squints on and let's start cutting. Whew. Sorry guys, this might be a little loud. Let me turn that down. All right. All right, check, check. All right. Let's see. That should be good. Okay, so here's my other din. It's cleaned up for the most part. So I just have one other thing to do, and that is this edge that's rough. I'm going to go over and I'm going to put it on the wire wheel and I'm going to brush it up real quick. Beauty. It's so nice having these tools when you need them. So what I just did is I took that burr that was on that edge, and by running it through a brass brush that's on my grinder, takes that edge off. So now it's much less likely that somebody's going to cut themselves. Pretty important. There we go. Okay, so now I've got my DIN. Let's find out where we're going to mount the DIN rail. So these guys mount just like so. All right, let's do it. Okay, so I've got these two right here. The goal is to make this come up here. So I believe, okay, I believe this right here is a pretty natural position for them. Yeah, something like right there. And let's see, where are you? I just spilled something all down the front of my thing right here. Okay, let's see. Let's put them up right about there. Let's do this guy. Okay, so that's what we're going to do, is we're going to put one in one side. There we go. Right there. Wow, that was really close. Beauty. Nice. Okay, so these guys here can move around. Again, I'll find a way to lock those down later. All right, I think it's time to turn the camera again so you guys can see even better what I'm doing. Okay. So right here are my two contactors. They're technically screwed down. All right, well, I will definitely deal with that later. So this guy here is going to go to a ground bar, which is probably going to be right up here. These two here are going to feed into the first one. And let's see. So as I said earlier, it is really important to know which is your switch port and which is your activated port. So these ones up here are your coil that's going to activate your contactor. Come on, there we go. Yes. Beauty. So now you can see how I'm running them in parallel, just like so. Let's see. No, is my number two too big? So if you guys do take notice, I'm trying to keep the hot on one side and the neutral pretty continuous. The only time I reverse that's over here, but that's all right. So my second ground bar, where are you at? I know I threw it off to the side because I didn't think I was going to use it. Oh, right here it is. Excellent. So this guy is going to naturally come right over here. There we go. All right. Yes. Okay, so this guy's going to screw down right here, and then my other two grounds are going to run over to my gang box eventually. Let's see. Ooh, wow, that's torquey. Oh, wow. That was not so good. My fasteners are not long enough. Hold on, guys. Let's see. Some of them are too long. Yeah, it's way too long. Oh, that's a good one right there. Go through. Yeah, close enough. Good enough for government work, right? This guy right here, I wish it was longer. Ouch. Should have known that was going to happen. Sticking my hands into a bunch of loose fasteners. Of course that's going to happen. All right. Oh, right there. That's what I'm looking for. That guy right there. Beauty. Nice. Okay. Put the magic fasteners off to the side. I'm sure I'm going to need them again. Okay, so these two are here. I need to wire in the outputs. So the output of one is going to be over here to the isolation transformer, and the output of the other one is going to go straight up here to my GFCI. Pretty easy. Got some extra screws. And let's see, I gotta still prove Bjorn wrong, because he thinks that this is going to be a really tight fit, which I know he's right, but it's all good. Okay, let's see. So I need 2 wires. All right. Well, this is going to be the one thing that I'm maybe not doing the spec. Hold on, guys. So this is normally low voltage wiring. I wish I had some really cheap power cords. Hold on. where do I have some really cheap power cords? I know I got them here. Some 2 conductor power cords is what I need. Yes. Let's see. Oh, look at that. Nice. Oh, bonus. I found some really good ground conductor. So let's save that one. And I do believe that this one right here, yeah. So this right here is going to be 120 volt rated. So this is going to be my output to activate the relays, the contactors. So this is what I got to go into that box. All right, so let's see. All right, y'all. Let's see. So it's got to go from in the box, which is going to be, say, right about here, and it's got to come up here to activate those 2. Let's see, right about there, and let's go a little bit longer. Right about there. Okay, there we go. There's these 2. Now, as I said before, my neutrals are all going to be bound together in here. So that's one of the things I got to do is separate out which one is going to be my switched and which one's going to be my neutral. There we go. Nice. And these 2 cables together are going to have to go into the gland nut like so. Ta-da! Nice. And these guys at this end, are they going to be long enough? Let's make sure that they're long enough first. Ouch. There's those 2. There's these 2. So if this guy's here, yeah, they're long enough. Cool. So let's go ahead, and there's 2 different conductors on there. One of them has got stripes on it. One of them's smooth. We'll make the smooth neutral, and the one with the lines is going to be our hot. Let's go ahead and strip them all back. Nice. And more of these guys. There we go. Excellent. This is coming right along, guys. Here we go. So those are going to be the ends that are going to come up here. These ones here, I've got to bind them together now. So let's detect these are the 2 neutral. These 2 right here are going to get the eyelets. Let's go ahead and strip those back. And let's see, where's my mini terminals? That would be these ones. Oh, not that one. And this one. Okay, I'm just double and triple checking to make sure that I'm not reversing the polarity on these guys. Man, that would make some arcy sparks. All right, and I need to crimp these guys. down. All right. Nice. Okay, so those two are going to get wired here to my switch. And these ones here are going to get bound together. Let's go ahead and strip those. Okay, let's see, I've got extra trash on my table here. And they're going to get bound to this neutral right here. And let's see. There are a couple different ways of doing this. I was going to use a crimp terminal, but these ones are not big enough. All right, so let's see what I got over here. Yeah. Okay, so what I'm going to use is I'm going to use one of these and one of my favorite materials ever, shrink tube. As if that wasn't predictable. So I'm going to shrink tube this guy onto the cables, and we should be good. All right, let's see. All right. Let's cut this guy in half, like so. Let's go these neutrals together. You know something? That shrink tube should fit over these. Let's go ahead and try it without the shrink tube on first. Okay. So what I'm trying to do is get them in a nice little knot there together. Yes. That is actually pretty good. Good, good, good. Now, mind you, these are only signal wires. It's going to be extremely low amperage, so I do not feel bad about doing this whatsoever. And, you know, critics are going to be critics anyway, so let's do this. Let's put that right about there, and let's shrink it down. Almost sounds like my battery's getting low on this heater. If you can imagine, a heater sucks a lot of amperage, so I've got a 5 amp hour battery on this heat gun, but I could put like a 6 or 8 amp hour on it. Okay, let's fold these guys up. So this is one of the advantages of using the heat gun, is it also makes these wires much more pliable, which means they're going to be easier to fit inside this box. Much easier. Thank goodness. There we go. All right. You see me positioning the wires a little bit and then shrinking it a little bit more. Go. So the trick is you got to let it cool down before you can let go of the wires, because you got to have all those wires together as close as possible. Oh man, ooh, that is hot. But that's also going to be a good thing. Okay, so this neutral, what I'm going to do is I'm going to fold it back into the case like so. The wires are nice and warm, which is nice. And, or maybe I don't have to. Nope, I don't have to. Good. So since I already have all my wires crimped and everything, I'm just going to go ahead and tighten down the gland. And the gland wants to spin. Of course it does. So I'm going to hold it with these needle nose. Yes. Okay, so this guy is just going to kind of tuck in there. The ground is going to do what grounds do. Let me use the needle nose to get that ground down where it needs to go. Well, Bjorn was not lying that this box is going to be a little hectic. But I think I got it. I have it. Yes. So let's say if I'm shaking, guys, is because I have had multiple cups of coffee this morning already in preparation for what is sure to be a brilliant live stream. There's nothing like waking up on a 3-day weekend and having lots of coffee. Okay, so let's see. This guy, I want him to sit around about here. Right there. So there's my ground wire. Done. But that makes it really difficult to get. Crap. Okay. Well, what I'm probably going to end up doing is drilling this guy right here and putting in 4 fasteners instead of the 2. Horrible design. Let's see, where's my other end cap? Right here. You can see where they put the fastener location. Square in the middle. Absolute garbage. Is what it is, guys. Right. So all I got to do now is put this one here and this one here. And let's see. Oh, you know something? I don't want that one there. Sorry, guys. My first real screw up. The reason being is it's off, on, off. I want it to be like this, so that the top one is the top electrical, which is a standard configuration, and the bottom one, I want it to be like this instead of sideways. I messed that one up. My bad. So the bottom one is going to be the isolated power. And that way there it's intuitive, because it's going to be down here at the bottom, you know. So let's see. There's that one. And I guess it doesn't really matter which one goes to what. Let's put some of these guys in here. Come on. Aye. Now, a more correct thing to do would be to probably put some heat shrink over these guys. That's all right. I'll fasten them down but good so that they never come loose. That guy, and this guy. I'm still wearing my safety goggles, guys. Safety first, right? Okay, there's that one. There's that one. There's that one. Okay. Let's see. Now that The only one that might give me some problems is that common neutral that I've got in there. Let's see. Yeah, that common neutral is giving me some problems. I just got to tuck it around good enough. And jeez, man, I don't really want to mount this sideways. I almost feel like I have to, though. Yeah, shoot. Alright, guys. Well, I wanted to mount it up and down. I don't think that's a realistic expectation right now. Okay. Let's see. Let's get this guy out of the way. There we go. Okay. Well, that right there almost does it, right? Yes, sir. Yes, sir. That's good. Okay. Before anybody breathes, let's hurry up and let's get those fasteners in there. Oh my goodness. So before I apply power, obviously the first thing that I have to do is check continuity between all my terminals and ground. Because when you cram things into a little space like this, there's always the possibility that you're going to get one little conductor that kind of slides out and grounds out someplace. So that's what I got to do next, is check for any continuity to ground or shorts. Come on. Well, is it working? Yep, there it is. There it is. Oh, whew. All right, guys. All right. So, yeah, it's going to be a little bit of a tight spot, but gosh darn it. I wish I could have done it better, y'all. Oh, it's number one. Do I have a number one Phillips here? I don't think I do. Close enough. Okay, this is probably not the right thing to do, guys, but it's going to speed up this video a little bit. Yeah, it sure did. All right. And let's see, I've got two on this side. Oh, come on. Nice. Nice, nice, nice. All right. Stick that one back. Okay, folks, things are really kind of looking up. Good, good, good. So, man, Well, tell you what, I'll change that later. There we go. All right. I want it to be mounted over here a little bit. Gosh, I still want it to be mounted straight up and down, kind of like that. I still think that that looks cleaner. Okay. Oh, come on. Sorry, guys. There we go. Jeez. I don't know how long that camera was out, guys. I don't know that. I got the little box installed. Gosh darn it, guys. I wish it would give me some sort of indicator or something when there's a mix-up. So one of the things I would like is for this to be like up here somehow. Shoot. And I would like this guy to be straight up and down somehow, like that. Do you think that looks too cluttered, or should I mount it sideways like this? I could do it like that. So this way here is normal power, this way here. Yeah, that's how I'll do it. All right. So now what I got to do is I got to figure out this one here, which terminal is being activated, right? And that's going to take a little fancy dancy meter here. Sideways. Yeah, we'll mount it sideways, guys. Just like this. Okay. So we'll put it right there. And one of the things I got to do is I got to check to make sure which side is hot on this. Okay, so we're on continuity mode. I'm on hot. Let's check for anything else. Okay, so here's the switched hot right there. Let's try the other side. Hot. Beautiful. Okay, no continuity. Let's check for ground. Beautiful. So my ground is working. All right, so let's check ground to any of the other pins. Nice. So let's check my neutral. Okay, everything is exactly where it needs to be. I'm very surprised. It worked out. It worked out. All right, tell you, let's do it one more time for this guy. Let's do continuity hot. Come on, continuity to hot. Okay. So you can see how I'm bending my hots over. So let's see. So this one here is going to be for my isolated power. So let's go ahead and set that guy up. And it doesn't really matter what activates what. because it's just AC. So I'm going to put my hots down here on the bottom. Right like this. It's about time for me to change the camera angle again, guys. Okay. So we've got these two. I'm going to separate the conductors a little bit. There we go. And then these two here are going to feed up just like so. Yes, there is a way to make it nicer and neater. Maybe I'll get to that some other time. I'm on a time constraint. Okay. All right, there we go. Yes. Okay. With just those there, like so, I can secure these cables like that. This guy right here. I need to drill a couple holes in this guy so that we can mount him and be done with it. Let's see. I have a massive amount of drill bits here, guys. Okay. Let's see. I want this guy here. Let's see. So I'll zip tie these guys together. Nice. Okay. All right. Let's get my board back so I don't booger up the table any more than I need to. There we go. And come on. All right. So I'm drilling 4 holes in it. Just like that. Yes. Nice. All right, so one of the reasons I got to hurry up and get this done, guys, is because on Tuesday, as soon as this holiday's over, I have to fly up to Philadelphia because I've got a project that I'm working on up there, and then I will be back mid to late next week, so I'll be up there for a while. And I hate having projects like this sitting around. If I say I'm going to do something, I am going to do it, guys. All right, there's that. Got to be careful because it's stressing that plastic a little bit. Definitely stressing the plastic a little bit. Okay. Nice. Yes. Progress, guys. Progress. Okay, so my 2 contactors. These guys are going to go over here. I should and I could shorten these 2 cables. I probably will. They should be shortened just to make it nicer and neater. But I zip tie them together like so. Make it look nice and beautiful. These guys are going to get zip tied together. It's going to look nice and beautiful. Okay, next, let's do it. Okay, this table is getting more and more stuff on it as we go. I wish I can stop those guys from moving around. We have the isolation transformer, the big boy. Let's go ahead and let's pull him over. I'm going to have to get some special hardware for this guy. Oi. Okay, so one of my goals is to leave these guys right here out in the open. Oh, come on. Come on. All right. So I do want to leave these guys over and exposed because since they're isolated, even if you touch them, you should be okay unless you touch two of them. But even then, it's only like 35 volts AC. So this guy right here is going to be my mains for this guy. And these here are my secondaries. So if my primaries are here, that means I'm going to have to create a cable that kind of goes like here. So maybe from this one, underneath, along the side, and up. Something like this. That's pretty good. Maybe move it over a little bit. There we go. Something like right there. You guys are probably wondering, what the heck am I doing? This is an old woodworking trick, guys. Right there. X marks the spot. Okay, so make sure it's clear. And then I will go ahead and drill it because I want to put a 1/4 inch fastener all the way through with a fender washer because we got to support, this has got a lot of weight. So I got to support that weight right there. Let's go ahead and let's drill it. All right, there's the first one. That's my pilot. And let's see, that's going to be a 1/4 inch fastener. Yeah, let's do it. Ta-da! Okay, nice and neat. That's good enough. Good enough for what I need. Now I got to find a long bolt that can go through there. All right. Let's see. So I've got some of this hardware. Whew. Might be a little too long. That might be about right. Okay. And let's see. I've got an acorn nut. Yes, it's the right size. Thank goodness. Okay. And fender washers. I have a huge amount of hardware here, guys. Because this is where it's at. Okay, so here is my bolt. Here's a lock nut. And here are some fender washers, which are going to have to go on each side. So one of them will go right here. Look at that. It's so beautiful. It fits right in there. This guy's going to go like this. Oh man, that's going to look so good too. Okay, and let's put this guy here on the bottom. That one's a little bit long though. I can shorten it later. Okay. So I'm going to do a no-no, and I'm going to hold the acorn nut with a set of needle nose while I drive it down. Yes. Okay, so the goal is we don't want the donut to spin, And we've achieved that. It's got a rubber gasket on the back of it. So it's fixed. Nice. This is moving right along, guys. Nice, nice, nice. Okay, put our fender washers back. Let's take the heat gun out. Let's put this guy over here. So now what we got to do is we have to energize our primaries. And that's going to involve some shrink tube. And, I think we should keep going with the yellow. I don't know, just actually looks very clean. So let's see, yellow from here to here. Oh, check that. So I don't need ground. So go from here to here. Let's do it right there. There is no ground on this donut, in case you guys are wondering. It's because it's an isolation transformer. Come on. Let's see. Okay, I just want to strip it back a little bit. And what I'm going to do is I'm setting it up for this side right here. Let's go ahead, scissors. Scissors just work so much better. There we go. Right. Nice. Just trim it up. Nice. Beautiful. Okay. So as I already said, ground is not necessary, so we're going to go ahead and clip it. Just clip it with these guys. Okay, so that's the only two that I need from this side. And you guys guessed it, shrink tube. So right there. Come on. Come on. It feels really good sitting here by this air conditioner, but that's why it is not shrinking this down too quickly. There it goes. Nice and steady, guys. Oh, my battery is wearing down on this guy. I can hear it. Okay. And let's see. We're going to strip it back. Right there. Yeah, right there. And you guessed it, ferrules. Now these ferrule kits are pretty cheap, guys. I bought this kit here for like 30 bucks, and it includes the stripper and it includes the crimper, plus like 500 ferrules. I mean, you can't go wrong with that, man. So definitely a good gig. Everybody should get one of these kits if and when possible. So let's see, there's that one. There's this one right here. Nice. Now on this one, since it's isolated power, it doesn't really matter if you follow the wire color code, okay? It doesn't matter if it's one polarity or the other, because it's going to output 60 and 60 that's independent. You no longer have a ground reference, all right? So it doesn't really matter, but just for the sake of continuity, right here, you can see that I have my hot on the left and I have my neutral on the right, so the inverse is how I'm going to, I'm going to match it right here. Oh no! Guess what? I had blocked access to this terminal. Come on. There we go. There's that one, and neutral. So these are the switched lines. Come on. Come on, come on. There it is. Yes. Okay. And then I can put this cable back. I'm going to have to remove that one too. I'm probably going to have to cut these and make them shorter. You can see how much extra I have. That's all right. Okay, so this one here is going to come over, and that's going to be for my primary. And of course, we're going to have to use a full-length heat shrink. So might as well go ahead and put the full-length heat shrink on it right now, so I don't forget it later. I've made that mistake many times. Okay, let's see. Jordy T says, just tuned in. What are we doing today? We are making a training aid so I can teach people about electrical theory. It is an isolation transformer, you're right, and there's a switch, there's a couple of relays. So I'll give you a flow of how this is all going to go. So let's go ahead and put this guy on. It's going to fit all the way up here. All right. And let's see, that one, yeah, perfect. So I'm going to cut these guys back right here. And let's see. There we go. And let's strip them. So this is only 3 amps on this isolation transformer for the 1-to-1 ratio, which is the 120 volt. So it's not like we're going to be powering something incredibly power hungry, but it doesn't matter. So I need to trim back this guy right here just a little bit, not very far at all. And remember, we're not using the ground conductor anymore, so all that we need is the hot and neutral. So that's as far back as I'm going to take it right there. There we go. Actually, I don't even need it back that far. Nice. Okay. Trim this guy. Nice. Scissors, you got to be careful because they can nick the insulation on your inner conductors. So the ground right here is the one that I said I don't need. I could either pull it out, or I could just cut it off flush, which I'll probably just cut it off. Like so. Nice. Okay, so now I need to terminate these guys together, and I'm not really completely for sure how I'm going to do that yet. Let's put him back. So I do have some insulated crimps, which I could use. That way there I could disconnect it if I ever had to in the future. Maybe that would be a good thing to do. What do you guys think? Or I've got these type of crimps. And I thought I had some 2 conductor connectors. I would love to be able to disconnect that donut in the future. I have a whole bunch of connectors, power connectors, etc. Let's see. We got a bunch of DC jacks. I got some 3 conductor wiring harnesses. All right. Well, I don't know, guys. I might just solder those together. It is what it is, guys. We're going to solder them together. And that means more heat shrink, right? Bjorn says it's only a 3 amp rated isolation transformer, but I bet it can pop that circuit breaker in case of a dead short. You're right, and no matter what, it's going to pop. I have a fuse that's going to be up here in my disconnect, so there's several redundancies. All right, so my guys over here are 20 amp, so these guys here are technically a weak link. I've got my circuit breakers, which are 20 amp. And then I might, in my main disconnect right here, I'm thinking about putting maybe like a 3 amp or a 5 amp into the main fuse. I know that doesn't follow standard electrical procedures, but it just seems that it makes more sense. I don't need 5 amps running through this system at no time. And maybe it'll just be safer if I limit it to like 3 amps. So in case a student does something stupid, it's not gonna, blow everything up. Okay. Yep, that's what I'm gonna do. I'm gonna solder them together. People that say, oh, you should never solder mains, connections, yada, yada, yada. Well, that's why this is a training thing, because I can do things that you wouldn't normally allow. Okay, Milwaukee soldering iron, check. Let's get some good solder. Check. And let's get a little bit of paste flux, because some of these wires might be a little dirty. Boop, boop. Yeah, should be a little bit dirty. The good thing is I am saving quite a bit of space on this board from what I was expecting. So that's good. That's really good. All right, so if I'm soldering the primaries, I might as well solder the secondaries as well. So let's go ahead. Okay, soldering iron is heating up. This is the Milwaukee soldering iron. Does a pretty bang up job for being a field unit. Right, and let's see. Let's also put some flux on this bad boy right there. Okay, and I think it's already up to temp, right? No? Okay, I guess green is heating. Oh, nope, it's up to temp. Woohoo! All right, let's do it. Let's solder, let's tin these wires. Yeah, I already know there's going to be some old timers that are going to be like, never ever solder mains wires. Well, this is all stranded, and it's actually probably going to be a lot safer if I just solder it. Okay, and last one. Oh, come on. This wire is not wanting to cooperate as it gets warmer. Okay, so one of the things that we definitely have to make sure of is good penetration, because if you solder, especially with these thicker conductors like right there, you see that there's no penetration on the bottom, which means I got to flip the wire over and I got to feed some in from the other side, make sure that it's very wet. Beautiful. You can actually see it creep down into it. Okay, so that's the primary side. So what we're going to do is we're going to line these bad boys up. I already got the heat shrink tube on there, so we're going to line them up parallel, solder them down, and then slide that heat shrink back up. So you guys can kind of see how I did that. It was quick and easy, almost effortless. Now, just slide that heat shrink up over the connection. This is all dual layer because it's much more protective. Okay. And let's get these two ready. I didn't stagger these connections. I kind of wish I did. And I hope I'm staying in frame because these wires are just doing what they want to do. Come on. Right like that. Come on. Ooh, these wires are definitely getting hot real quick. There we go. It's like magic when everything just kind of works. Good. We got a good bond there. And now I gotta slide that heat shrink up. Come on. Let's do it. So right here, I've got a little problem with the insulation wanting to bind up. No problem. I kind of wish I had better lights right here. I know this shop is really well lit, but when you're doing like soldering and stuff, man, I love having a nice bright lamp right on me. Okay, so that's looking pretty good. Beauty. Okay, both the connections are preserved. Now let's shrink them. Nice. So if those two are good, I've got my outermost heat shrink tube, this one. And put it so it covers both that insulation and this one right there. Ooh, my battery, I can hear it. It's wearing down. I don't think it's going to last, folks. All right, that's going to look so good. trying not to focus the heat down at the donut. So I've got pretty good glue adhesion at both ends. Definitely feel good about that connection. All right, so let's take a look at what we have here. So I'm going to be able to set this guy kind of in this configuration right here. That's my primaries. My secondaries are ready to rock and roll. So far, so good. Hold on, let me check the comments, y'all. Sorry. Solder sticks. What would be a good option? There's really not much of a difference between a lot of solders. I use leaded solder instead of unleaded because it's better to work with. She says, I have a TS100, mine is tiny compared to the Milwaukee one, but it's a different use. Yeah, that's true. That's definitely true. How many degrees do you use for that heat shrink? I actually, it doesn't really matter what temperature. The Milwaukee's got one heat setting that is just hot. All right, so it is just hot, hot, hot. That's okay, because what I have to do is just adjust the distance to the source, and that's how you're going to control your temperature. Now, when it comes to solder, the only thing that really matters is the gauge, which is the diameter of the solder. And make sure that, so I use 6040 leaded solder is so much easier to work with, but a rosin core solder, which most all of them are right now. And this diameter here is, what is this? 1.22 millimeter. This is my favorite because if you get too thin, it's okay for like small connections, but this one here is small enough that I can get it into fine-tuned areas, but it's a larger diameter, so I don't have to feed so much into larger connections like these ones. That's really it, is how much solder do you want to feed into your connection, and what's the gauge of the conductor that you're soldering. Because if you're using a larger gauge conductor, you have to use a larger gauge solder, because otherwise you're just going to be feeding so much into the joint. So this one here is my favorite, the 1.22 millimeter. It's beautiful. Comes on what, 1 pound or 500 gram spools. Definitely the best. Let's see, let's leave that one here. Okay, so my secondaries. So the way it's going to work is when this guy is over here, now my my isolated power is switched. So that turns on my primaries, and now my secondaries are going to have isolated power, which is going to come out and over to the gang box. So let's see, I have only yay much cable left. Come on. All right. I think I have about 5 foot of this yellow left. So I've got enough for this guy here to run from my secondaries to the gang. And then the other one is going to run straight from here or to the gang. Good stuff. So one of the things I'm thinking about here is I said that I have a couple indicator lights that I want to run. And I have to still figure out how I want to run those in. So here's one of my indicator lights. It's kind of cheating because you want your students to look with the multimeter to see if it's energized. But this is also going to be, it's going to give me a, it's going to give me an instant notice like, hey, it's hot. So I'm just curious if I should run these over by the gang box, like way over there, or keep them like here next to the source, or if I should keep them here next to this guy, because I could easily wire it in. But it doesn't tell me if I have output from my transformer. If I have it in line with my gang box, now it tells me that I have power going all the way over there. So this is my little conundrum. I'm figuring out, should I put it here right off the contactor so I know that, hey, my contactor's on? Or should I run this guy along with my power to the gang box? Or maybe even place it over by the gang box? Let me go ahead and clean up some of these tools so that you guys can see what I'm talking about, because I'm starting to have a mess here on this table. My crimper, my multimeter, so much stuff. All right, my cable, which I'm going to need again. Oh boy. I just sensed that I'm going to tip something over. Okay, let's see. I don't need an ink pen. Don't need this. Strippers. Yes, crimpers. I don't think I'm going to need crimpers anymore. Okay, guys, time to adjust the camera angle yet again. All right. Let's zoom all the way out. And let's raise you up. It's all right, guys. We'll get you a good solid camera angle. Okay. So this guy is definitely hot. Here, I'll shut him off. All these drivers. I wish I had a little caddy cart here next to me so I can keep this stuff organized. Okay. There's definitely a lot of tools, guys. So here is my gang box. Here are my outlets. And let's see, here's my other indicator light. Throw him over there. And let's see, I won't cut any cable yet until I lay this out so you guys can see exactly what I'm planning. Oh, cool. So I chose an all metal gang box because this is where people are going to be plugging in and plugging out. And I want it to be really sturdy. So that's why it's all metal. And also because I can make it really good ground point, which you can see. The plastic gang boxes don't have that luxury. Okay. So I do have two end caps that I can screw in, which I'm going to place, I was thinking about running the power cable from the top and the bottom, which means I'm going to put these caps in and I'm just going to drill them. Okay, so there's some little strain relief right here. That's cute. So these caps here screw in like this. And what I could do is I could drill from the side 2 holes, and I can run 2 of these, like right here and right here from the side. Do you guys think that looks maybe a little more professional to run 2 gland nuts off from the side and then just mount this straight in? To which then I'll keep these end caps sealed just like that. So, yeah. There's 1. There's 2. It's a metal box, but it's going to be super easy to drill because it's just cheap metal. There we go. Then you can see my 2 receptacles there. What do you guys think? Should I just put the gland nuts in through the side? Hold on, guys. My remote or my mouse is buried. There we go. So I can read your comments and see what you guys suggest. Is this an isolation circuit for a maintenance station? This is an isolation circuit to teach people about electrical. Because when you have an electrical safety analyzer, like what we use in medical technology, we have our own electrical safety meter. And the thing is it will give you a different scenario, or it gives you like an error code if you plug it into an isolated power system. It tells you that there's a problem with the ground circuit. Well, that's something that I want people to see, and they can see it just by connecting it. So I've also got a GFCI that's going to be on there, and the GFCI, it's an important piece too, because it's technically like a limb, only when it senses current between ground and neutral, it pops, you know. But that's something that we can test, so that'll be cool as well. So that's why I've got an isolation circuit on there. Okay. If it's going to sit on the stand, I would suggest placing the light at the back. It is going to sit on a stand. So do you guys think that I should put the indicator lights someplace else? I don't even have to put indicator lights on it, to be honest. I thought that it was going to be safer if I do, so that I could visually see that it's energized, you know. Because there is a 3-position switch on there, and it could be technically off, which you would see. But I was going to put the indicator lights on to kind of show that it's on regular power or it's on isolated power. Do you guys think that I should still put those indicators on there? Or, tell you what, how about this? I could also put the indicators, because of the way that these guys here are wired, you can see that there are multiple terminals. All I would have to do is you put your line in on one side, and then on the other side, you can wire these in, right? So instead of being through the back of the board, they're here, and then I can drill through the side panel here and mount my light sideways. So technically, I would know just by walking up to the side of the machine if this one's energized or this one, you know. But this guy's going to be a through panel, probably around about there. Only thing I have to worry about is the GFCI, making sure that there's enough clearance there, you know, because this guy here is like 1.25 inches long, inch long, something like that. And these run at a full 110 volt mains. All right, so there was a 12 volt option, but these ones here run at full 110. So let's see. You really have to be careful that the solder really flows between. Jordy, I've been soldering for many years, so I definitely check my connections. That's not a problem. Let's see. Color and white transparent. So you guys are talking about something else. I think it indeed looks better. Okay. For that reason, I use black zip ties, which you were right about the black zip ties, by the way. Good on you. Backside wire is better. Okay. Okay. Well, let's see. Indicator light may give away the clue of the students. Let them measure the wires are hot or not. So Bjorn, you think I shouldn't include an indicator light whatsoever? You're probably right about that. I can always add it later. I can add that later. It would be a dead giveaway. I mean, all they'd have to do is look over at the side of it instead of measuring. You can see the GFCI is a chunky little girl. When she is in there, it takes up quite a bit of space. Okay, we'll leave off the indicator lights for right now. We'll see. I'll keep them because it's an easy addition. All I gotta do is take the gang box apart and re-drill it if I really want to. Okay, that's a good on one. So next, let's see. These guys are gonna go up here. Let's throw the indicators over here. So what I'm thinking is on my gang box is to drill it and have these two gland nuts coming in from the side instead of coming from the top and the bottom, because these two right here are, I don't think it would look as good. Not nearly. So, I do think that that's going to be a solid choice. Now the only thing that I have to be aware of is that it does have this hex nut that retains it. So I just have to make sure that they're far enough away from each other that that's not going to be an issue. Okay. Challenge accepted, man. In order to do that, I'm going to take these two retainers. I'm going to kind of lay them out. Oh, so you guys can see what I'm doing. Okay, so here we go. I'm kind of laying them out like so. So my two wires come in nice and beautiful. Something like that. Perfect. And I also want them to be pretty low. Right about there. All right, and in order to do this job, let's see, I should have an automatic center punch here. Huh. Oh, what have I done with all my tools, guys? I have like a bunch of these center punches too. Oh, okay. Okay. None of this matters. We're just going to drill it. I was going to do it all proper, you know, for you guys, but fact of the matter is I just need this guy to be done. Okay. So the way I'm going to do it is I'm going to figure out roundabout where it needs to go. Mark it. Oh. Boy, it really grabbed on that pop metal. Okay, let's see. Let's do it from the front. Okay, right there near the point. Oh man, I'm missing all my tools. Okay, right there. Check. and it's over just enough. Darn it. Oh well. We're just going to do it, guys. All right. Yeah, it's close enough. Not exactly dead on, but close enough. And last time I had some really good luck with these taper bits. And yes, they're going to make an absolute mess of my desktop here. Yeah, let's do that. And for this, I'm going to turn down the torque, or the rotation speed. Oh, yes, sir. Yes, sir. This DeWalt is very strong. All right. Yes. I think I'm going to have to put this guy in a vise. Because it is getting tough to hold on to. Let's see. Let's put this guy in some clamps. About that. Oh no! My clamps aren't large enough. Okay, guys. Problem solving. Beauty, just like that. All right, I understand that you guys can't really see what I'm doing. I'm trying to clamp this guy down because I don't want to break my hands. All right. Yep. You can see this whole table like grabbing. That's the safe way to do it. Uh-oh. Just move my clamp over. It was hitting the pot metal of my clamp. There we go. All right. Whew. Okay. And how's that? Close? No dice? Perfect. See that? Nice. That's how you want them, nice and tight. All right, got a little bit of metal shavings all over the place. Not exactly what you want when you're working with electrical, right? So here are my two my line ends. Let's go ahead and put these retainers on here. Actually, hold on, guys. Let me deal with the metal. All right. There's nothing worse than getting metal shavings up in your arms. Trust me, it's happened many times for me. Okay, so first thing I got to do is put my through panel nut in there, and then I'm screwing it into it because there's so little clearance. I did that on purpose just to get me close to what I wanted to be. There it is. Nice. Yes. Perfect. So there's my two gland nuts all set up. This guy here is going to mount just like that someplace. Let's see. And I don't really have anything else to put in here. So I guess maybe I'll just leave him down here. Perfect. Let's do it. So next I'm going to drill the case so I can sink my fasteners down into the wood. That way there, this guy here is not moving all around on me because that's going to be an absolute nightmare. Okay. Nice. Nice. All right. Let's get rid of the metal. Nice. Nice. That was a little bit faster. All right. There we go. Let's go ahead and back this guy out. So, I'm thinking something right around there. I was going to put it up at the top. I don't know. What do you guys think? Gosh, hold on. So do you guys think I should put this near the top of the board or down here near the bottom? I mean, it's just really an aesthetics thing, but I mean, ideally I'd have two gang boxes, but it is what it is. Let's see. I think I should probably put it up here near the top. Because if it's sitting at a table or something, this is where people are going to be easiest to measure voltage. Oh, hold on, guys. Or a little LED hideaway to the back so you can see it, but they don't. I might actually wire that in maybe after the fact, after it's up and done. See, you can use a little bit of heat shrink over a ferrule and the screw not tighten. Yeah, there's actually a bunch of different things I can do with screw down terminals. Yeah, no, this drill here is strong enough to break your wrist, so you have to be really careful. The box is made of so-called Zamak and short scrap. Yeah, it is. Can't be welded, but it's good enough for enclosures, brackets. Yeah, okay, that's definitely true. Okay, interesting. All right, so here are the fasteners to hold this guy down. Oh well, didn't need that flashlight anyway. So let's see. Let's put him, say right there. That looks pretty good. Solid. There we go. Sunk in. Nice. Okay. So now I've got two strips that I'm going to have to cut. One of them is going to be for regular, and one of them is going to be for isolated. So, looks like that is about how long my isolated is going to have to be. All right. Yeah, it's looking pretty solid, Bjorn. And you know, if it doesn't look completely professional, well, that's okay. I'm actually all right with it not being the absolute best, because this is going to be a training aid, which means it's going to be traveling. It's going to get roughed up for sure. Okay. So this one here is going to feed through the bottom gland, like so. And if you guys are wondering about the ground, that's why I've got this bus bar right here. So I'm going to run a separate ground wire, which I pulled out. I've got some really good ones here. And let's see. So I'm thinking I should just run a separate ground from this terminal in through a gland nut next to one of these yellow wires and then connect it. I think that would be the best way. Let's get rid of this guy. And this should be, yes, a yellow terminal. This one right here. Okay, let's crimp him down. There we go. Okay, so this ground here, it's going to come up and it's going to ground out my chassis. Oh, let's see, do I have enough space in the gland nut? Yes, I do. Yes, I do. Nice. Nice, nice, nice. Perfect. Ah, come on. There we go. Nice and tight. Okay, beauty. There we go. I know it's kind of a janky way of doing it, guys, but this way here, my ground will come right here to my local bus bar, and everything that's in here should be at that potential. Let's see. Can I move these wires over? Yes. Okay, so you can see I'm tucking the ground down as much as possible so that my receptacle can sit freely. And I have, let's see, this is going to be isolated power, so it's going to have to go here. So the rule of thumb is black to brass or it's your ass. Since this is stranded, the most correct thing to do would be to use Y connectors, which I think is going to have to be yellow. Let's cut the ground off. Okay. Oh, the blue works. I was thinking that it wasn't going to be the right diameter. Okay, let's see. Where's my crimping pliers? There it is. Jeez. There we go. And this one. Now, guys, the only reason that I'm using these terminals is because this is not solid core. So if you guys are wondering, like, why the hell am I using crimp terminals on AC mains? It's because we've already determined that it's not going to carry a huge amount of current. In fact, I'm probably going to put the main fuse as like a 3 amp. That way there it saves my isolation transformer just in case. And black to brass or it's your ass. So neutral goes to this one. Okay. And I am not going to mount these inverted like you would see in a medical facility. These are going to be standard configuration like you would see in a house. So these ones here, let's go ahead and drive these in. And last but not least, the ground terminal. So I'm going to do something special for the grounds because I ran this guy here in I'm going to ground the outlets to the other one. Sure, let's do it. And I need another yellow connector. Ooh, let's see. Oh, geez, guys. I need to stock up on my crimp connectors. Let's see. I cannot believe I don't have any more crimp connectors. You got to be kidding me. Okay. Ah, there's no way. Hold on. I do have my toolkit here, so... Oh, there we go. That's what I thought. So in my professional toolkit, I've got way more connectors. There we go. Beauty. So I needed the yellow just because of the diameter of the wires. And because I'm using stranded, I'm going to use crimp connectors. Perfect. I even have a bunch of fuses in there. Nice. Okay, so let's do the grounds. Most important thing first. And one of the reasons that it's most important is because I have a GFCI in there, and the GFCI is going to be reliant on a solid ground in order to function. Okay, so let's see. Ta-da! Well, right about there. Nice. Okay, there's one. Oh, shit. You guys can't even see what I'm doing. There we go. Should ground cable have its own port? No. It's not going to matter for this. For normal electrical work, you can have more than one ground bar, but if it was for audio equipment, you'd get... Well, you know something? Luckily, I am not creating any ground loops. We can test it, but so far I'm not creating any ground loops. Technically, my first ground loop is going to be up here on these guys. You'll see in a minute. But it's going to be so short, it's not going to matter. So a ground loop is whenever you have multiple items grounded at the same time, but with different length conductor. And what it does is anytime you have a conductor, you have something that can carry and induce current. And when you have one conductor that's longer than another, you now have a difference of potential. And when you have a difference of potential, your wires will start creating anomalies. That's the best way to put it, anomalies. So that's what Bjorn's talking about on your grounds. Come on. Come on, missus. Are they not stripped back far enough? No, they're not. Dang it. Okay. Nice. Okay. Come on. Okay, so what I'm doing is I'm feeding them both into the same crimp connector. So I can crimp it down. There we go. Jeez. Okay. So now what I'm going to do is I'm going to connect this ground over here to this side. And then each of my outlets, oh, come on. Wow. Come on. Almost cut my hand. All right, let's try it again. Come on. I should just be using the socket to drive these. Why don't I? Let's see, is that the right size? Close. With that one. Yes. I don't know why I bothered so long with the flathead. I could have just did this right from the beginning. There we go. Now they're definitely torqued down. You're probably wondering, why the hell did I do it like that? It's simple, because I'm only switching the hot and neutral, which means I didn't have a ground, which means I have to put in a ground, which is what I just did. Run this guy over here, underneath to my ground screw, like so. Nice. Okay, there's one set. Come on. There we go. And I guess I should tuck this other ground before I get too carried away. There we go. So that one comes over to the GFCI. And if you guys are thinking this is not to electrical code, you would be right. You would be right. And then some. All right, here we go. There it is. So you guys can see I'm not driving it down so that I can still move it around a little bit. That is because you want to align your faceplate. So leave it loose like that. So it's almost tight. You can still move it around. That way there, when you go to put the faceplate on, it lines up beautifully, okay? Next. Let's put this guy over here. All right, so this guy, we have to come over and it has to go to my secondaries. That's gonna be another piece of shrink tube, of course. Between the two ground loop, the two ground bars, I do not have a loop. Nope, because they're going to be at the same potential. You see, this one here comes over to this one, and this one here goes to here. It's technically in series. See that? It's not technically a loop. The only loop is coming right here, because I have them grounded here common, and then it's running up to these two. So this here could be the only potential loop. This here is actually in series. See that? Just like that. I guess I might as well do this guy up while I've got it here. Let's go ahead and cut it down a little bit. And I'm going to need another ferrule. And this one's a thicker fair rule. All right. I don't feel like fighting it, so I'm just going to put a larger one on it. Beautiful. Man, these things always look so nice when you put them on. There we go. This guy here is going to be here. Nice. Beauty. Okay, so I need to trim this guy back just a little bit, enough to expose the hot and the neutral. Come on. There we go. So I'm going to cut the ground on this one. Right. Okay, let's get rid of the garbage. Okay, so ground is useless. We can clip that guy like so. And now we need the heat shrink. I bet you guys are wondering how much heat shrink I really do go through. Man, a lot. I go through a lot. There we go. So here's the outer one, and then all I gotta do is the two inner ones. Let's do those next. Nice. Okay. Strip these guys back. Let's tin them up and let's solder them together, and then I've got my isolated power circuit done. All right, let's get this guy back. A little bit of this here. Okay. That was flux, if you guys are wondering. So, next challenge is the fact that I gotta strip back some of this because I'm running out of space for my shrink tube. Come on. There. That should be pretty close. And I believe we're hot, so let's go ahead and solder. Let's do it. Nice. You can see on my neutral conductor right there, it is wasn't good enough. There we are. All right. Okay, so I trimmed it back a little bit further so I could slide these guys on. That's what I'm going to do right now. Now we just line them up and solder them in parallel. Which I wish I could set up the camera to show you guys how this works out, but you guys get the drift. Soldering, soldering. Come on. Woo-hoo-hoo-hoo. There we go. Nice. Nice, nice, nice. Perfect. And now my hot conductor. So for this one, I'm going to add a little bit more solder to the secondary. There we go. So there's a nice bulbous section on there. Beauty. There we go. So now let's shrink those two down, and then we'll put that guy on there. Let's see. I think I need to change out my battery though, because this guy's had a hard life already. Let's charge. Okay, this one is only like a 2 amp hour or a 3 amp hour. She'll get the job done, no problem. Nice. This fresh battery is definitely making quicker work of it. Okay, so here's that one. Now we get the outer sleeve. Give it a good tuck so I can get the fiberglass insulation. Man, that's looking good right there. Okay, so I'm going to kind of force it that way a little bit as I heat shrink it. There we go. I'm trying not to focus the heat towards the coil. Nice. That's looking really good. Okay. So now, since the wires are nice and soft, I can kind of craft them how I want them. And I want this one here to lay pretty flat, so that's why I'm going to kind of force it down. And then as the glue hardens in there, it will kind of maintain that memory. Good. All right. So I could technically energize this guy right now, and I would have isolated power here at this receptacle. Now, I guess I have the easiest one now, right? I've got the GFCI, which is going to run through here, just to right here, or right here rather. So just a little loop up and in. And then this project is almost done. This one here goes through the gland, comes down to here. Say right about here. Pretty good. Okay, so what I'm working on right now, let's go ahead and shut the soldering iron off. I don't think I'm going to need him the rest of the project. So what I'm going to do now is I'm going to strip back and cut off the ground, which is the green. And this is going to be for my GFCI, which is the normal power, non-isolated power. Okay, there we go. Take the ground, strip it, cut it, etc. Here we go. Nice. Okay, so these two here are going to need some of the same yellow spade connectors. Actually, on the other one, I think I put blue on. So the different color connectors also are inherently closely tied to their current capacity. So blues carry less current possible than the yellows. All right, well, I have a little bit of everything there. Okay, so this guy here is going to come from here, and I do need another piece of shrink tube for this guy. And let's see. I had a piece that I cut off that I didn't use yet. Huh, well. Okay, so let's see. That is the exact outer dimensions. So I'm going to show you guys a little trick. Let's go ahead and trim it to size. So if you have a piece of shrink tube that you want to install on something that's the exact size, this is how you can do it. So you can see I've got a set of needle nose, and I'm rotating it, and then stretching it, and then rotating it, and it will fit on your cable. Okay? So that's a trick that I learned a long time ago. If you need to, use needle nose to stretch it out, because shrink tube is already stretched tube. So all it's doing when you heat it up is it's returning to its natural size, its natural dimension. So it's stretched at the factory. So there you go. There's that one. I just need it to come down a little bit. And because this is dual layer, it wants to like stick to everything. And that's okay. Normally a little bit of rubbing alcohol on this, and this guy'd slide right down. Not a problem. I'm kind of being gentle with it right now. Come on. I just need it to come down just a little bit, and then I can strip this back. There it is. Okay. So I just need to put two more connectors on right here. Those are ferrules. And again, cut the ground. We don't need it floating out there for no reason. Okay, it's looking good. All right, here we go. Let's cut this guy. My cutters here are falling apart. There we go. Beauty. Okay, fair rules. I need 2 ferrules. Perfect. Okay, so now this heat shrink that I sneaked down, I'm gonna go ahead and raise it up a little bit. Come on, come on. Just right there. So these 2 terminals are gonna go right there, and I can shrink this guy down. There we go. Excellent. Okay, so again, my black, which is hot, is on the left, so I'm going to make sure that I do it exactly the same. Let's pull out this one. Nice. And let's see. Okay. And then I've got this guy up here. Screw him back down. All right. Now these 2 guys are set up. So last step, to have this guy come up here through the gland, and just got to put those 2 crimps on it after I get it through the gland, like so. There we go. Nice. So that's the goal, is to keep the wires looking nice and neat and organized so that they sit beautifully. Here we go. And let's see, let's just strip these 2 back.
Dad.
Yeah, what's up, bud?
Mom is watching one of your YouTube channels that are live, and that's a live YouTube channel you're doing right now.
What's that? Hey, bud. Yes, I am. And in fact, there's a bunch of people watching as well.
Yeah, even Mom is watching.
Oh boy,
Mom is watching.
Mom never watches my videos.
Well, she is right now, and I came in.
That's because she's trying to incriminate me on something.
Alright.
I'm just playing, man.
Dude,
But not.
I saw one of your YouTube videos, and I decided to come here, and it's real.
And it's real.
Because it's live.
Yeah, because you'd figure like I'm just out here goofing around, right? But come to find out, it's actually happening in real life.
Why do you have this big pack of wire?
Why do I have a big pack of... Oh, well, that's a transformer, bud.
Transformer?
Yeah, you know, like the movies, like the Transformers.
Yeah.
it's well, a transformer is technically just what you said. It's a coil, and those coils can do some pretty important things. All right, bud. So, kids, right? I don't know if you guys heard. My son came in. Let's see. Normal electric work, you can have more than one ground bar. Yeah. Got that. Another type box. No, this one's going to be easy. This one's easy. Yeah, but daisy chain ground wire. No, daisy chain ground is not considered a ground loop. That's technically not true. So ground loop is when you have multiple devices. Let's say I have two devices that are going to be plugged into the same power strip. Happens all the time on like audio and video carts. Let's say one of them has a 3-foot power cord and the next one has, let's say, a 10-foot or 12-foot long power cord, which does happen, and they're plugged in the same power strip. Well, technically, if those two devices are touching case to case, then what you're doing is you're creating a loop because it's going from this one into the power cord, and it's going through the chassis of that device, touching the chassis of the other device, which often, if they're on a video card or something, you do have touching equipment, and then it will go into this ground. So what you have is a loop. That's your ground loop. So that's what would be going on. What's up, sweetie? How you doing?
Hey, Daddy.
You come all the way out here to see what I'm doing? You did. You guys are so curious. You guys are never curious about what I'm doing. Do you want to fix things when you get bigger?
Yeah.
You do? You just made my heart melt. You've never...
Just said that you were making a live YouTube video.
Well, I am. And would you know that I'm almost done?
Really?
I'm almost done.
So for until...
I'm really close to being done. Like right now. Because I've been working on it for a long time now. I've been working on it since I think before you guys woke up. Yep. All right. Okay. So this is going to get a little complicated. Here we go. Let's drive this guy in. Okay. So, in the world of not following electrical codes, it's the Better Biomid special, you know. So, I do have the ground connected, the hot's connected, everything's good. I just need to seat these guys and bring it down to earth. Okay, here's my GFCI, which the GFCI is still fighting me over here on this fastener. All right. You want to help me with this? Yeah? Tell you what, I've got 4 final screws that you can help me with. Does that sound cool? See how this plate, it goes just like this? What? Is that cool?
Yeah.
Okay, so first off, I left these loose for a reason. Okay, so this guy here has to move over a little bit. Let's try it right there. Okay, so that one looks good. I was definitely making a live video. I've been making a live video for a while. Okay, so this one's good, and this guy here, I've got to move just a little bit. Right there. That looks good. Right there. Let's tighten them down.
What are you trying to do?
So these are electrical outlets, just like in the house, right? And what I have here is, look at all these wires that I have on this board. Do you see that?
Mm-hmm.
This is like an exact duplicate of kind of how electricity runs in the house.
Oh, those plugging things are plugged.
Yeah, yep. These are regular plugs. That is true. Okay, so you have the most important job of them all, right? Okay, see a screwdriver right here?
All right, then I'm going to tell Mom.
Okay. Just like that. Okay, now do this one.
No.
No.
Hey, Mom, are you watching this?
You don't
I know
tighten.
you're there.
Don't tighten it all the way down, okay? We gotta tighten them in sequence. Okay, here you go. Let's do this one. Okay, a little more on this one, please. Yep, right there. No, a little more. Keep going. Keep going, keep going, keep going, keep going. Pretty good. All right, let's move to the next one. There you go. Good job. Keep going, keep going. You're pretty good at this. Okay, let's get that one right there. Got it? Wow. All right. Good job, sweetie. Okay. So that one looks pretty good. That one's pretty good. So we can't tighten them down too much because they'll break, right? So we just got to tighten it just enough. See that? Boop. There we go. Doesn't that look like an outlet in the house?
Yeah.
Yeah.
And it just moved.
No, it doesn't move. It's down.
It's heavy.
Well, of course it's heavy.
I can't lift it.
Why would you want to lift it? It's screwed down. Okay, so I got one gland nut right here to tighten down. And you can see how the wires are kind of sitting out. So what I need to do is I'm going to drill some tiny little holes in the board, and then I'm going to zip tie around the cables here, and then I'm going to route this one here just like that. Okay, so probably a zip tie here, zip tie here, zip tie here, and obviously I got to organize these cables. But this guy is technically ready to go. Look at this. Do you guys see the switches?
Yeah, I see you, Mom.
Look at this. Clunk. Clunk.
Dad, what is this?
That's a 3D printer, sweetie. Do you see these switches, Addie? See that?
What are you meant to do?
Look at this one. Pretty neat stuff. Are you ready to learn how to use a multimeter?
Yeah.
Yeah, I'll teach you. Okay, so you see red is off, green is on. Right? Okay, guys. So we have the GFCI right here, which is connected to my regular power, and my other one is connected to my isolated transformer. That's selectable through this guy right here. And I'm going to actually probably cut off this whole section of board right here. I was really surprised that I was able to do it within 2.5 feet. I thought I was going to need the whole 4-foot long board, but that is not the case. Let me go ahead and switch camera views. There we go. All right, so now we have one of the most important things of all. What do you think it is? It's cleanup. we gotta clean up some of these tools, girl. Look at all these tools. Okay. Screwdrivers. Okay, guys, you ready to do a function check? Now, mind you, I can't energize it at the moment, and that's because I don't have the fuses. But I'm going to travel down to the hardware store and go and grab some fuses. Should have did that beforehand, but hey, just is what it is, right? Hold on just a minute. I'll let you guys get a final view of what the whole thing looks like. And let's see. Let's put this guy over here. Yeah, I'm actually kind of happy that that came out the way it did. Let's disconnect this guy here. And this guy here. All right. Ready? We're going to go live, guys.
Yeah.
Woo! What are you doing, Addie?
I can see you, mother.
All right.
Hey, mother.
Yeah.
I'm getting
Yeah.
you.
Yeah, I got you. I got you. Okay, guys. Let's see. Okay, so this is how this thing is designed to work. So right here, when I'm doing anything inducing bugs or whatnot, I'm going to have it locked out right here.
What comes to lock?
No, this one here. You can put a lock on it. See? It says on, off. Okay. So there's some cool things that we can do with this type of box. Come on. Yeah, this is very hard to do with one hand. So one of the things that we can do is we can put in defective fuses. So that's a good one, because if people don't check their incoming power, then how do you know that everything's good, right? Is it plugged in? Always got to check your incoming power to make sure you got power. In your house, that would mean that you just check the meter. This one here, you don't have a meter, you have your disconnect right away, which you can measure in the disconnect, which I'll let my students measure in the disconnector if they want. But really, it's safer to go right here. These, I'm going to find probably 5 amp fuses to put in this. So 2 5s. That would make it much safer. So right here are my circuit breakers. I do have all 3 hot, neutral. Oh, come on. Hold on, guys.
Oh, it says click on start.
Yeah. That means that it is not happy with me walking around.
So,
Hold on.
Mo, if you're watching this, oh, I'm coming for you.
So shut up. What are you doing? You goof. All right, hold on, guys. Hold on. Apparently, the battery was not charged enough. Okay, guys. So right here are my circuit breakers and my bus bar, like you would find in your house. I can open neutral. I can open ground, both of which will induce some very funny things over here. I do have 2 contactors right here. So we can actually test out various things, like how do you know that your contactor is energized? We can test that right here. Do you have activation voltage? Do you have primary voltage? Do you have output voltage? You can test all that there. We can test this guy. You can test your isolated power systems. You can test, do you have power on your primary side? Do you have power at your secondary side? We can test that. We can also test other things like the other secondaries, because a lot of transformers will have more than one secondary. So we've got 3 sets of secondaries right here. And it's safe. You know, yes, it's 30 or 25 volts AC, but it's still technically safe because you're still isolated. So that's why I left those guys just dingle hoppering out like you see right there. Okay? I got 2 bus bars right there that are both ground. They're in series. And we'll just finish it all up right here with my electrical switch, or my my GFCI. So this one here, you should register 60 volts and 60 volts, and neither one of them should have continuity to ground. But on your GFCI, you actually should have continuity from your neutral to ground. So hot is always going to be your small pin. Neutral is always going to be your larger pin. So anyway, I'll give a demonstration of it as soon as I get those fuses, and we'll see where we can go from there. Anyway, guys, that was, I know that was kind of a crude and lengthy video of me putting together a project. You can see how thorough some of my project is. So my initial plan, this is how my initial plan was. And other than the LED indicators, which I foregoed at the moment, everything else seemed to have been perfectly planned out. So now, what happens when we energize it? So I'm going to go ahead and do a regular video of that. And that's going to be probably coming up next really soon. So anyway, guys, thank you for tuning in, and I hope you guys were at least somewhat entertained. I mean, it's a project, and projects are just a lot of labor, and this is a meticulous project because we went through everything from DIN-mounted hardware, industrial electronics, went into circuit breakers, went into main disconnector, and none of this, by the way, should be taken as gospel, okay? Because what I'm doing here is not standard electrical practice. A lot of these lugs require a certain amount of torque. I did not torque down any of mine. In fact, before I energize it, I'll probably go back through with a screwdriver once again and check them out, all right? So I know that this is a little bit of a different project, but I'm gonna go ahead and maybe hack off a whole section of that board, trim it up, and router the edges so it's nice and beautiful again, sand it down. And then I've got some piano hinges here. I've got a collection of piano hinges, and this is how I intend on making it stand. So a piano hinge is a lengthy hinge which will close almost entirely on itself. They come in various lengths. This one here, it's just long enough so that I can make maybe 2 wings to the sides. Haven't really figured out how I want to make it stand yet. One of the ways I can make it stand is like a U-joint. So you make a mating surface between the legs and the base, or you can use like a piano hinge so that the legs are always attached. They just kind of fold in. Hard to say, but first I'm going to do a function check and stuff, and we're going to test that out. All right. Okay, guys. Anyway, apparently the kids are getting very bored, and it's Labor Day, so y'all enjoy your Labor Day. I'm thinking that mine's going to start probably right about now. All right. Thanks a lot, guys, and stay tuned for my video where I actually put this into practice. And I think I might actually do a video maybe with the kids showing them how to use a multimeter on live mains, because I do believe you can teach anybody safely, including my little 6-year-old daughter. So, guys,